Okay, Ben, did you want to walk through installing LandKit 2.1 beta?
Yes.
And so for anybody who has LandKit, this is also, we want to make that consideration as well, like how to uninstall that and then install the new version or
Yeah.
upgrade.
And one thing to keep in mind here too is that it should be very similar for Rhino 7 and Rhino 8. So if things look a slight bit different, if you're on Rhino 7, just keep it in mind that things should still be in similar spots for like what we're going to be showing you. So you can
Yeah.
open a blank file of Rhino or any Rhino file that you have open already of any kind. And once you open it, you'll just make sure that you have the command line selected if it's not working already, and just type in the command package manager. And so you can see that up here in the top left-hand corner where I've typed in package. I start typing in package and package manager comes up. You can hit enter as soon as it starts to show. What will happen when you do that is it will open up this little window called the package manager window with two tabs at the top called online and installed. So for those of you who already have LandKit installed, let's start with that first. And what you can do is you can head over to the installed tab and you should see the LandKit uh, uh, file or package here in the like installed list here. And you'll probably notice that it says like version 2.0 or version 1.8 or 1.9 or something along those lines. But here in the bottom left-hand corner, there should be a little checkbox called Include Pre-Releases. And you want to make sure that you have that selected and checked so that it will allow you to see versions that are beyond the available full version. So if I navigate over here to something like Elefront, you all can do this on your LandKit when you install, if you have LandKit installed. When you do the drop-down version, once you have that selection, include pre-releases checked, you should see options here that say beta available. And what you'll want to do if you already have LandKit installed is go to LandKit in your installed package manager list, go over here, select the dropdown for the version after you've checked the pre-releases, select the very latest version. What should be, is it 2.1 beta, Chris? Yeah, he's writing it on the screen there. It should be 2.1 beta. And you'll select that and you'll hit install. And then when you do that, you'll have to restart your Rhino. Make sure you close out of all of the Rhinos that you have open on your PC or Mac. And then when you open it back up, you should have that latest version installed. Now, for those of you who don't have LandKit installed already, you'll want to navigate over to the Online tab here of the Package Manager. And in the top here, in the search bar, you can just type in land, or you can type in land_kit. Land alone will bring up, the three options here: Land Art Tools, great set of tools, Caster, which I'm not as familiar with, and LandKit. And when you select that option, again, you want to make sure that you have this checkbox here called Include Pre-Releases selected. And when you do the drop-down menu here, you should see this 2.1.0-beta.1 option. Just like I was saying with those who already had it installed, select that option, hit install, and you should be able to restart your Rhino, all of your Rhino files that you have open, close them out, open up a new Rhino file, and you should be able to navigate over. Everyone should be able to navigate over to the installed package manager tab here, and they should see a LandKit option with the version 2.1.0-beta version installed with a check mark next to it. I have mine installed through a different version because we do a lot of testing and I have a slightly more updated version to test a few things. So that's the reason why you're not seeing it on my package manager. But if you're running into issues during this process, or you're not seeing it installing correctly for any reason, just let us know.
Yeah, that does bring up an interesting point. So not only is Ben using an ever so slightly newer version, he has he has it installed a little bit differently. Has anyone installed LandKit by just putting it into the components folder, which is like a very used to be a very common way to do that? Um, no one's done that, right? Everyone's doing this through the package manager.
I can go ahead and run through how to get rid of that just in case they have installed it that way, Chris.
Well, if nobody says they have, then it's not a big deal,
Okay. Okay.
because no one's done it that way.
It's been a while since we've done it that way for anyone.
Yeah, I think most of the time, like we use the package manager. We have like a little installer script that relies on the package manager. So it's usually installed that way. And we just want to make sure everybody, we know this is a little installation can be a pain. Part of this is that different people are installing different ways sometimes, and sometimes their IT manager is installing that, and we just want to make sure that everybody is has what they need for the workshop. Now, the
Yeah.
reason we're doing beta 2.1 is because we have a few really cool new things to show you in the advanced workshop. So you guys are part of the, let's call it the avant-garde of planting design today. So
Uh,
um, yeah,
One thing I wanted to add into the installation process, Chris, and for everyone else too, just to make sure that you know that everything's working, and this is something I always do through other workshops, no matter how complex we're dealing with the material, is once you finish reopening your Grasshopper script or opening up your Rhino after installing, open up Grasshopper really quick. Just go ahead and click the Grasshopper button or type in Grasshopper in the command line and make sure that you see, first of all, the Land Kit tab. And when you see the Land Kit tab, you should be seeing all of the components fully saturated. Most notably, these components, if you look closely, that have these little red dots in the top right-hand corner. If you don't have all of these fully saturated, and it'll be pretty obvious that some of them are a little bit faded or translucent and have some opacity changes to them, then that indicates that you're missing your license key. And so that would be a key moment to let us know if you don't have a license key, a trial key for some reason, or you just haven't inputted it yet, and we can make sure that we walk through that. We do have a lot of online on our website tutorials on how to kind of walk through that. But
yeah. Is Westervelt, how are you doing over there, Westervelt? Do you guys want to?
I'm having trouble keeping up with you, but oh, I think we just figured it out. So on the land kit tab, everything
Mhm.
should be saturated. Okay,
yeah,
we're there.
Yeah,
We're good.
it is. Sweet. Good.
Thanks.
Absolutely. And also, I'm here in the chat, and Yautza is also here in the chat. Yautza's on our team, and can also answer questions. And when I'm talking, Ben will be available. So Ben and I are going to go back and forth. And that's maybe we should start there and do some introductions. So I'm Chris Landau, the founder of Landau and the creator of LandKit, and um, I'll turn it over to Ben and Yautza to introduce themselves from the Landau team.
I'm Ben or Benjamin Summy. I've been working with Chris for some time now through pretty much the entire development and creation of, well, most of the development of LandKit for the vast majority of its creation. And I lead a lot of the educational and support aspects of LandKit, as well as a lot of the projects using LandKit at our firm for consultation work.
Hi everyone, my name is Yao Zhe. I work with Chris for like almost 2 years, and I've been exploring LandKit a little bit during the journey of the working here, and also I've been managed to working on the computational projects and some visual storytelling projects. Yeah, so nice to meet you guys, and I could answer any question if you have in the chat. Yeah, thank you.
Maybe we'll do Ishan next because that's kind of
Hey, my name is,
Ishan's
can you
helping
guys hear me?
us.
Yeah, my name is Ishan. I was recently an associate at local office, but I worked at Scape and MBVA before that, and I've joined a couple of these workshops now and really believe in the potential of LandKit. I'm looking forward to this workshop.
I can go next. My name is Amanda. I recently graduated with a master's in landscape architecture and one in planning from Cornell, and I'm working at a firm in Ithaca.
Hey, I'm I'm Allegra. I work for Westervelt Ecological Services. We do very large scale Ecological restoration, like hundreds of acres. So I'm super excited the possibility of helping us with planting tens of thousands of plants. So thanks.
Hi, I'm Andre. I'm from Nature Culture. We're based in Dubai and Italy. Yeah, we just recently switched to Beam for almost 2 years now, and then we found out that we need to automate our planting workflow, which we searched to the web and we found Chris and the land kit, and from there we're very interested in developing this into our system.
Nice. My name's Alex. I'm at CMG in San Francisco. Very excited to be here. Similar thoughts to you, Andre, as well.
It's good.
Very exciting. Yeah, we are really excited about planting design. Obviously, we wouldn't be spending so much time on this if we weren't. But in particular, we want to enable folks to be able to scale their planting design in different ways, both at like literal scale, but and using algorithmic design to be able to sort of work at very large scales, very large quantities of plants. But we have to sort of learn the rules to do that. And we're going to be looking at that today. But then the other scale is in possible complexity that computation can help us solve that our feeble little human minds can't always handle all of that complexity all at once. And if you can build all of these things into an algorithm, it can have this kind of memory. And then also scale in terms of biodiversity, which it often is really challenging because we have a hard enough time dealing with the complexity that we're dealing with. And so the idea that you could set up an algorithm that could solve planting design based on all the rules and the layout that you're giving it, but then just add quadruple the plant list, and oops, now it works with even more plants. So really some exciting stuff. Ben is going to get started just for the agenda today. Ben is going to start with really the basic principles of rules-based planting design by showing you the planting workflow. And the cool thing about the planting workflow is you don't have to know any Grasshopper. It allows you to explore where plants are placed based on a few simple rules, but it does have its limitations. And so then the rest of the workshop will be us really diving into and really swimming in the ocean of all the crazy things you can do with the planting tools. And some of these are going to go way over certain people's heads, and certain things are going to go way over everyone's head. But we want to make sure that we give you all this context. We're recording this, so as you learn, you can always revisit this and sort of say, "Oh, I see what they're doing there." And so this will be like a resource for you moving forward. So it's not just where you're at now. It's some of it is a little bit aspirational, and I say that now so that when people go, "I'm not following all of this. Oh my God, why do they expect us to follow everything?" We're going to try to keep everybody with us as much as humanly possible, but there will be some things I think where I will literally say, like one of my demos, I'll say like, "Look, I don't expect you to understand all of this. This is pretty crazy," but it just shows the potential, right? But for now, let's get started with something that is very understandable and very easy to get into, which is the planting workflow, which we have available. And to be fair, is also due for an update. So please also watch for an update coming in hopefully this year. Before the end of the year, we'll be updating the planting workflow the way that we've updated the Topo workflow recently. Excellent. Well, Ben, do you want to take it away?
Yeah, absolutely. I think one or two other comments that we want to kind of throw into the mix here is we're going to be trying to kind of balance this idea of zooming in really closely into like these really advanced concepts, but also giving like a big picture of like what is the goal of what we're trying to do in this script or in this function or in this like particular instance. And so I'd really encourage everyone to, if you have questions, just throw them in the chat if you want to, but if they seem important enough for everyone and it might be missed or it might be useful for the recording, we definitely want to make that available by talking about it out loud. So if you have something you think would be super beneficial for everyone, feel free to just, open up your mic and chime in and say, hey, like, I don't really understand the big picture of this, or does it do this, or how does it relate to this? And we can make sure that we answer those questions for everyone. And in addition to that too, as you're seeing a lot of these really advanced and unique approaches to planting, feel free to, after the workshop, throw in an email or a comment to us about, hey, like, it would be really cool if the planting workflow could do this. Because we really want to make sure that we're trying to gear the planting workflow in the way that we're seeing could be useful based on a lot of the work that we've done with people in the past. But also, we want to be attentive to the things that you all are seeing that other people are not experiencing in some of these advanced concepts as well. So Chris has just dropped a Dropbox link into the chat. You can download that and open up, unzip that folder if it comes in as a zip file. And that should be all the files that we're going to be using today. I think it might make sense for me to just kind of like walk through the workflow. If you want to open it and you've experienced it before, maybe some of you have already utilized it in some fashion. It does require another plugin, but I don't think it's totally necessary that everyone open up the planting workflow right now, because we're really just using this as a way to show you what it can do, but then also introduce some concepts about rules-based planting and the different pieces of the puzzle that come together to make the planting tools that we have function well and efficiently that will apply directly into the scripts. But essentially, the purpose of these workflows that we've developed, whether topo, planting, or the pattern and paving workflows, is to get you out of the Grasshopper space and get you out of that scary space of Grasshopper and into a UI interface or a user interface that allows you to just kind of very simply understand the basic flow of how to use some of the planting tools and what they can do. And so the planting workflow begins with the info tab, giving you a little overview, and then the plants tab, which allows you to import the plants that you're going to be utilizing in a variety of different ways, as well as filter those plants in this plant list in particular ways as well. And it looks like I accidentally just opened up the AI plant list. We're not going to get too deep into that today, just because we'll be making a lot of changes to that AI plant list. But the sort of big picture approach to this is to be able to bring in a plant list as a CSV file. And there's a couple different CSV files that are included in that package that we have introduced to you. For 90% of this workshop, we're going to be using the ERA database. But for the planting workflow portion of this, I like to use the plant demo. So I'm going to open this up. I have the plants tab that I'm on. I have my plant list source as plants from CSV. And then down here, we have the plants data CSV browse for importing. You go ahead and select that. Again, you might not have it open yet, but again, for the purpose of the recording, for you to come back and follow along and try this out if you want to, we have in that package, we have a CSV file called the plant workflow demo. And this is just a really shortened version of the ERA database that allows us to really easily see what's happening with the rules-based planting approach that we'll be utilizing for a lot of the workshop today and the way that the actual tools function. So I'm going to go ahead.
I want to make sure that everybody is
Yeah,
following
go
at
ahead,
this point for sure. So just to review, we want to open up the planting workflow Rhino file, and then you can basically just drag that planting workflow Grasshopper file right into that space, and it should open up immediately. And then it'll open not immediately. It opens Grasshopper. It takes a second. It has to process. And then Grasshopper will disappear in this case, which is very unique and different, right? Like, we're not used to this, which basically just means that you have a new little user interface here on the side, this little side panel. And then under the Plants tab, you're going to browse for that special CSV file that Ben shared, which was the plant workflow demo CSV. And the reason we do that is because, well, it does a few things. We have a larger database that we can refer to, but this smaller database gives us a little bit more focus and control for the workshop. And okay, we have a chat here. And it shows you that you can include your own database, which we're going to talk more about.
So the planting workflow Grasshopper file for some reason never copied over when we copied it over this morning. So
Yeah, I
I
was gonna say
copied
that.
over. If you want to re-download the participant package to include that, you can, or I just drop a link in the meeting chat that will automatically download that Grasshopper script. I'm unsure as to why that never came over, but that should be the Grasshopper script you work with. And I think one other thing to note here for anyone who has already tried to open up that planting workflow file is if you run and drag that Grasshopper script into the window and it doesn't, and it throws a bunch of errors, it gives you a bunch of error comments like you're missing a plugin, it's probably because you're missing the plugin Human UI, which allows us to create this interface and utilize it. So you can go ahead and click download and install when that little window comes up saying you're missing a plugin. Click download and install, close out your Rhino, open it back up, and then you should be able to utilize this workflow. Even for the advanced concepts approach of trying to teach these concepts that we're going to be diving into the Grasshopper world for, the workflow in every avenue of LandKit really helps understand the big picture ideas of what things are doing before you really see the Grasshopper script nitty gritty. So it can be quite
yeah,
nice to have that.
if anybody has an error or anything like that and wants instruction as they go along, please just pop it in the chat, and I'm going to be trying to watch so that Ben can keep going. But Ben, I think it's okay for us to go at a slower pace in the first
Okay.
round here. We want to kind of make sure
I'm sure
this
everyone's
is like a base minimum. We want everyone to be kind of like playing around with this for sure.
Yeah. Okay, well, hopefully a few of you are starting to get things up and running a little bit. I don't want to, again, I think as Chris mentioned, we don't want to rush this too much. I have a tendency to get excited. So, if I start going too fast, feel free to slow me down. Anyone or Chris.
Well, Ben, why don't you start providing some context for
Yeah.
what the planting workflow does, and then I can I'll just field any questions here on the chat.
Yeah, so big picture, what it's trying to achieve here is it's giving us a few basic ways of approaching the rules-based planting, where we're able to bring in a small, large, medium, any size CSV file that has a whole list of plants in it. And I'll even double click and open up a really small version of that for you just so you can kind of see it. You have your plants with different columns with different characteristics, and each of the plant species by their scientific name, and then some of these lists also have their common name, have a series of characteristics that kind of continue on based on how we've laid it out and the template from this other CSV called the ERA database. And we'll get into that a little bit more later. But the general gist is that we have this very basic format of plants in the CSV file that the software can then interpret and read and sort out those characteristics to each plant so that you can then use those characteristics for placing the plants on the site based on those different rules and constraints that we're applying. And so the plants tab here allows us to import that CSV, but it also allows us to come down, and if you have it open and you're looking at it or not, you can scroll down, you can see that there's all kinds of ways that we can filter and modify and be very specific about how we're selecting different categories or groupings of plants that we want to use for the specific project we're working on, whether that's filtering different plant types that we're using, selecting states in which those plants are native to, and even just individually selecting different species that are already pre-filtered by those categories that we maybe do or don't want to include. And then what will happen after you have your plant list imported and the plants that you want to use really specified based on the different filters and categories that you're trying to utilize is that we're then going to go over and we're going to start to constrain those plants based on environmental and design conditions. So you have one big category of importing your plants and filtering them into the category and group of a smaller list that you really want to focus on using. And then you turn your attention towards the site itself and the inherent environmental conditions that are a part of that site, such as your sun exposure or the soil moisture that you're outlining, and then also even design considerations that you're implementing, such as flower color or pollinator value, or even any type of other custom constraint that you want to deal with. And in here, we can modify that site and those constraints and how they're being implemented in a variety of different ways, whether that's selecting one or multiple different constraints to be utilized and overlap that will place the plants based on all of the characteristics that apply to those different constraints, or just one of them, depending on how many of these different constraints you're utilizing. We can change how we're laying out the plants and how we're sort of sorting and applying densities or shifting the plants around and packing them into the space. We can change the level of detail or quality of our analysis that's affecting how the plants are being placed, and even affect some of these constraints and analysis parameters specifically, such as indicating a specific location in the world where we are planting so that the sun and exposure vectors are accurate as much as possible. And then the final step of the process, after you've figured out your plant list and brought it in and sorted it, and then identified the constraints that you're dealing with and set those up and specify the details of those constraints that are important and specific to your site or your design, is to modify and select the outputs that you're dealing with, whether that's trying to deal with some two-dimensional plants that are going to be used for a planting plan with unique glyphs or block shapes and types that you can see here that we have custom being created on our site, or whether we are trying to utilize some sort of 3D representation of the plants, whether that's a simple spherical massing or some kind of 3D customized representation that is still very rudimentary, but gives us some sort of indication of different forms based on the plant type and the size of the plant. And then we have a couple of other considerations for how to bake these things out into different file types, or in this case, automatically have them baked out as blocks, as they will automatically do in this workflow and will happen throughout the workshop that we're doing here, and some analysis previews that allow us to kind of see the different analysis layers that we're utilizing and how they're affecting the site, and then be able to kind of relate those to the plants in particular ways. How are we doing, Chris? Are we in a pretty good
Yeah.
spot?
How are we doing, guys? Yeah,
So for
I know, I
intro
know,
list,
I know a few people. I know a few people have gotten things kind of like working, um, and if anybody's getting anxious now about they're getting behind, Ben is just giving a big overview. We're going to kind of walk through these steps a little bit more methodically. How many people are pretty sure that they have this working? Okay, so we have, so you're missing some of your components. Amanda, I would re-download, and we also want to make sure that you have MetaHopper. You don't have human UI. It looks, oh, do you? No, you do have human UI.
Yeah.
I would re-download that script, and because sometimes what will happen is someone will open that script and save it. Like if things aren't installed properly, it'll save and then it will it will save it without the proper components. That usually fixes it if you just re-download. And
Which one to re-download? Sorry.
the Grasshopper, so the planting workflow
Yep. got it.
Grasshopper script.
Okay. Thank you.
I would just close it down and then reopen that Rhino file and use the freshly downloaded Grasshopper script.
And Grasshopper can be kind of finicky in that way. When you open up a script that has components that you're not using, if you then close that file out and accidentally hit save, it will save that Grasshopper script without the components that you were missing before. And then when you open it back up, it's just like missing those components.
Yeah. The workflow has an auto save function because we want people to be able to save their settings and have it save the Grasshopper file without being in Grasshoppers. And this is one of the things we want to fix about the planting workflow, among others, but it's something we do find. So how is everyone else doing? Is there anyone else stuck?
Yeah, I think I got mine running. Okay.
Great to hear.
Allegra, is everything going on well on your end?
Oh, good. Okay. All right. So as soon as Amanda's is working, we will have everybody going.
No pressure, Amanda.
Yeah, no pressure. We just want to make sure everybody's good. And the part of the reason I pause like this is because sometimes these problems will reemerge for somebody who everything worked fine today and but then they have this other error later. In this one in particular, to kind of start with a fresh download of the planting workflow is a good idea.
And more importantly, too, I think on top of that is as we make updates and modify the planting workflow itself, it's going to become robust enough to be able to utilize it in projects more readily. And so there might be a moment in the near future where you don't really want to use the Grasshopper scripts. You just want to use the workflow in your office because it's become so robust that having this sort of slow build up to this, I think is very useful for those of you who might end up using it. Oh, good. It looks like it's working for you there, Amanda. Okay, so the other thing that we want to make note of too is you want to make sure that you have the Rhino 0_planting workflow 2.0 file opened as well. So make sure that you have that because the workflows function notably by interacting with a preset template of layers that are being interpreted and read and fed into the Grasshopper script and processed with the planting workflow user interface so that you don't have to deal with importing stuff directly or manually into the Grasshopper script. So as you make modifications to your topography or the different zones that you're using to outline what's happening in your constraints, such as your flower color zones or your pollinator or soil moisture zones or custom shapes or your buildings for your sun exposure or trees, it will automatically update for you because it's interpreting these template of layers that you're seeing here on the side. So the names of these layers that come in as a part of the template are quite important. Hopefully, you want to get to a point where that changes too. Yeah, how's it going, Sean?
Ben, the human AI or whatever plugin, that's the one that gives us the workflow panel?
Yes, that's the one that gives us the workflow panel.
Okay, cool.
Yes, so if you see here at the top, once you have that downloaded, if you open up your Grasshopper script, you'll see a tab for human UI. You can see I have a whole bunch of plugins downloaded. You don't need to pay attention to any of those. But these are a series of components that allow us to create a script that looks super complicated, but some massive portion of the component that you're seeing here are directly related to creating this workflow panel, as well as connecting the different pieces of the land kit components to this workflow panel and the layers in Rhino so that you can create that interaction without having to jump into Grasshopper at all. So the workflow panel works directly from the human UI plugin. So hopefully we're all kind of like moving a little bit now, and let's start moving a little bit through an overview of what's happening in this planting workflow and how it functions here. So, like I was mentioning before, when you have this open, you probably won't see anything appearing. You won't see a plant schedule automatically appearing or any plants appearing in these planting zones automatically. And that's because we need to import our plants from a CSV file. So under the Plants tab that you'll navigate to, you'll notice that we have the option of our plant list source as plants from CSV. That will be the default option that is selected. There are some other options in here, and I would encourage you to avoid going to any of the others for now. We can maybe at the end of the workshop come back and revisit those a little bit, but we really want to focus on importing plants from a CSV for both the workflow and the workshop for now. Under the plant list import settings, you want to click the Browse button, and it will take you into your File Explorer, to which you want to navigate to that participant package folder you downloaded and utilize the plant workflow demo CSV that came with that package. If you're feeling bold and you want to use the ERA database, that's totally fine. It's just seeing how the constraints are working with the plants are a little bit more difficult because you're dealing with a much larger number of plants that have a variety of different constraints that make it difficult to see. And this shortened demo CSV allows us to see what's happening a little bit easier. And you can already kind of see that once you import that demo file, you'll notice that there are red plants that are being sorted into particular zones on our site that are different than some of the other like blue and green plants and even some yellow plants that are in those zones as well. And we'll be able to see what's happening in there pretty easily here in just a few minutes. So down below that, we have a couple of options here. We have the ability to save our plant list. That is something that probably becomes a little bit more useful if you're dealing with something like an AI plant list that you're generating. But if you're filtering out these plants from a really large database like the ERA, which has, I think, almost 6,000 different species of plants, it takes a long time for that to process sometimes. And what you can do is you can save a plant list with a smaller list of plants that you've already filtered in particular ways, and then load those plants in later as well if you want to. Did someone have a question? Or did I just hear like a hum? I probably just heard a hum. Okay. So down, if you scroll down in this plants tab here, you have your plants imported. You can see the different plants that are coming in here. There's a couple of selections here I want to make note of. The first being the number of species that we're importing. Now, if I open up this demo file, you'll notice that we have roughly 20 plants. You probably have about 19 plants. I think I have one added in here from a previous workshop of some sort. You're not seeing any plants after browsing. Okay, so you browse and open up the CSV file and you're not seeing anything at all? No plants whatsoever? Allegra?
Correct.
Okay. Yeah, Chris will grab a screenshot. Should we take a moment here and make sure that's working before moving on, Chris? Or
I think you can
I'll talk through some of these filtering options maybe.
talk through the filters. I think that
Okay.
could be helpful.
Because I think the important thing about these filters that you're seeing here is that it's going to start to be very evident once we jump into the Grasshopper script itself, how we're doing this and what the benefits of doing this are. And notably being able to select a specific number of species, it will select a random number of, in this case, 50 species from that list. Since we're using a plant list that only has about 19 or 20 plants, 50 doesn't really affect it in any way, shape, or form. But if I were to drop this down to 5 species, let's say, you'll notice that it pulls in only 5 species. So it's filtering out the number of plants based on this slider here and this choice. So I'll jump it back up to 50. But when I do that, you'll notice that we're not bringing in all 19 or 20 of those plants in that list that we have, even though we are telling it to bring in more than the plants we have in that list. It's not going to bring them all in because we're using a couple of other filters here. Most notably, the filter plant types. And the filter plant types, if we look at our CSV file, we have some shrubs, we have some perennials, and we have some herbaceous plants. But currently, we are only bringing in herbaceous plants right now. So let's go ahead and select the grasses option. And we'll notice that when we do that, it's going to bring in those grasses that are categorized in our CSV file as the graminoids, perennials. So now we have a much larger list here that includes both the herbaceous and the grasses. And if we go ahead and also select the shrubs, we should see that we are now bringing in all of our plants. But you'll notice that the shrubs, because of the size of them, are sort of filtering out some of the plant placements. So for the purpose of this demo, we're going to unselect the shrubs and just focus on using grasses and herbaceous plants. And we'll see that we have a nice filling in of different plants. Again, seeing some sort of pattern here that's coming through as to where these plants are being placed. And then if you want to, for your own purposes, you can go down to the check plants to include, and you can deselect some of these plants if you'd like to uninclude them from the list that you're dealing with. So we have this Andropogon here, Ternarius. If we want to not include that into the list, I can unselect it, and you'll notice it's no longer being included in my plants that are being placed.
Hey, Ben.
Yeah.
I just want to jump in here. I don't know if Allegra is seeing my chats. Allegra, I'm sort of sending you a prompt here if you wanted to
Okay.
send a
We have
screenshot.
not. Oh. Yeah, or I mean, would it be worth sharing our screen? Because we're just like, we have the CSV file, we just not,
Sure. Yeah.
it's not
Like,
loading.
it might provide everyone a little bit of
Okay.
context to some other,
Uh, hold on. We don't typically work in Zoom, so we're having trouble finding the
okay.
share. We found it.
Great.
And feel free to just click stop sharing on mine. Yeah, there you go.
Okay.
Awesome. So you've gotten that, and just can you scroll down? Okay, so you have, okay, so what you've done is you've, for some reason, deselected herbaceous. So you have said filter it so that there's no plant types, right? So if we select herbaceous, now hopefully you should see them pop up. Wait, hang on. I'm
Just
not sure. So
herbaceous.
just herbaceous.
Unselect the other ones.
And then I'm seeing something else funky happening there.
You know what I'm seeing, Chris? Open up.
What?
Go ahead and.
Oh, we don't have the pro key, looks
Yeah,
like.
the pro key looks like it's not installed.
Yeah.
Oh.
So let's
Okay.
let's open Grasshopper, and you should have a key that we sent you, right?
Yep, I do. Okay, hold on.
And
Let me dig that up.
We're not gonna, just for the purposes of
Yeah. Okay, so once we get the key back in, we should have this.
yeah, and if you installed the key and never restarted Rhino, that might be the problem. Because you can see how we're missing all those Grasshopper components, right? Like they're all kind of grayed out.
Okay. Okay.
Yeah.
Okay. We'll stop sharing and we'll try and catch up. So keep going.
Okay.
And if
You're so
it
close.
still doesn't show up, then yeah. Okay.
Yeah. Okay.
Thanks.
Cool. So I'll just continue through some of these concepts that we're seeing here and move into constraints as well. And then, again, since this is being recorded, if you miss any part of the workflow here, Allegra, you all will be able to go back and watch that too. But, obviously listen in and at least get some of these ideas that you're hearing in your head, because we'll be revisiting them in the Grasshopper script in a very pointed way. So, the last thing that we have here is, filter by US state, where you can indicate what plants you want to be native to that state that you're going to be utilizing, as well as being able to filter out the plants based on whether or not they have a flower color or a color assigned to them. A lot of data in this ERA database that we're going to be utilizing for a lot of the workshop, I'll go ahead and open that up too, is missing data. It's an open source database. It doesn't have every type of piece of information for every plant. You can see these cells that are just missing information for different species. So some of that information that's missing is the flower color itself. And you can see that some of these plants don't have a flower color value assigned to them. That's something you can go in and fill in yourself, but we just provide an option here that allows us to say, don't include plants from that database that don't have an assigned flower color, because we want to utilize plants that have specific flower colors. In this case, we're using all the plants, but all the plants have a flower color, so in the demo file, so it's a bit irrelevant for our purposes here. But now if you navigate, so now what we have is we have our plant list set up. We have it filtered in particular ways. In this case, we're not doing a whole lot of filtering except for that one andropogon that I removed from the plant list, and not including shrubs. And we can navigate over to the constraints tab now. And we can see that we have a couple of different categories of selections here. The first being the site size. And the site size relates directly to a really important principle of how the planting tools work in LandKit, and that is the creation of the environment. And so you have these really two major categories here. You have the plant list itself, and then you have the environment. And the environment encompasses the analysis that's taking place on your site. And we can specify the level of detail or quality or resolution that we are trying to apply to that analysis. So in this case, we have some preset selections for you already set up. But once we get into the script, you'll see how we can actually create our own custom site size. So the environment is this boundary, and Chris is going to be drawing some supplemental visualizations over here to the side. But we have this boundary that in plan view is encompassing all of our topography and our trees and our topography in every way. And inside of that boundary, we're basically laying out a grid of analysis points. And so we have this grid of points that are being generated inside of this boundary. And the spacing of those grid points are based on a value that we put in: 1 foot, 2 foot spacing, 50-foot spacing, however we're doing it. So the size of your environmental analysis boundary is as important as the spacing that you are assigning to those analysis points. A small site size is going to give you more points of analysis and create a higher resolution image of analysis that will give you a little bit more accuracy for your placement of plants. And then a large site size is going to create a wider spacing between those analysis points that will create a lower resolution of the image. But because you're creating fewer analysis points in the large site size, your software can process faster. So it's always a balance here between how large is the site you're working on and how detailed does that analysis have to be, as well as how fast do you need to process this and test it out. And so a lot of times you can kind of play between those and say, well, maybe while I'm kind of testing things out, I'll work at a larger site size or a medium site size so I can see things happening quickly and start to set up the different constraints and rules and plants that I'm dealing with. And then after the fact, when you're ready to kind of see a little bit more detail, you can drop it down to a smaller site size and let it process a little bit and get an output.
Hey, Ben.
Yeah.
Yeah, could you show everyone real quick? Just turn off the topography layers for now. It's actually, I think it's easier to see things this way. And you can, no, you can hide the grasshopper.
Okay.
Turn on the out tab and then show the sun exposure. Just, I feel like it's just going to make it easier for people to understand. So you can kind of see the cells here, right? So you can understand that we're doing this is the sun exposure layer that we're visualizing. And in that layer, we have values that are like sun, part shade, and shade based on our analysis tool. That's all, under the hood. But in order to change the density of those cells, you can change that site size. So if we went to, a large size, it gets even fuzzier. But if we go to a small size, it gets more detailed and articulated. And you can see that. Now, in our Topo workflow, we've added like extra small and extra large. And so we have a wider range. And there's ways to customize this if you need to. But this is the main idea, is that we're storing all of the analysis layers. Why is this important? Why is this different? When we typically do analysis for planting, we create all these separate diagrams right, of existing conditions, and they end up in a PDF as part of the early part of the project. And how often are we referring back to that actual analysis, or how can we keep all of that in our heads, right? And so the cool thing here is that it's saving all of this data, and keeping track of it so that when we go to place plants, it can say, no, you can't place plants there because you have, that doesn't work. So that's like the important thing. And we're setting up these rules and we're layering all these rules together. What was the last thing I was going to say? I think that's probably enough. I'll let Ben
Yeah, no,
continue.
that's super useful. And I think the other thing about this is that, we have this big idea about, this McCargian approach of like starting to layer these different analysis layers that allow us to see a new picture of like a suitability map for certain types of plants based on the layering of these different analysis layers that we're doing, such as sun exposure, color, soil moisture. But then actually handling that and categorizing each species of plants into the different zones that they can actually fit within based on their constraints is extremely challenging. But the nice part is that the software itself, because it's storing that analysis information into each of those locations, each location has a unique suitability set of layers associated with it, and the plant can then read and place itself near that if it applies to that. So when we're looking at this right now with the sun exposure map on, we're only using one constraint, but you can already see how the plants that are red prefer part shade, and some of these other plants prefer full sun and part shade, and some of them prefer only shade, and so on and so forth. So the ability to actually see just this one analysis layer working helps inform us that as we start to layer these things in, it's going to get a little bit more complex, but the software is going to handle that by creating those maps that are unique identifications that the plants can then interpret and then place themselves based on those constraints. So we'll keep the sun exposure on only for now. Actually, you know what? Since we're talking about it, let's just go ahead and throw in the flower color and just show a picture of what that looks like when we start to layer in another analysis layer into the mix
Yeah,
here.
and I think you could turn those off. It'll be easier once. It'll be a little easier to see the plants themselves and where they're being placed and not being placed if we just keep those layers off.
Yeah, I just turn them off. But if you look at it here, you can see that the sun exposure placement of these plants is still being utilized. But we're also now utilizing a flower color parameter where we're giving it a zone with a color. In this case, we have a bunch of yellow zones here, and only plants that have flower color in yellow can fit within that zone. But in addition to that, it also needs to adhere to the sun exposure preferences. So if you notice, if we start to shift this flower color yellow circle over into the part shaded zone, it's going to remove the red plants because red plants are not yellow. They don't have flower color yellow. So the layering of a part shaded zone, as well as requiring this zone to have flower color yellow plants, removes certain plants from that zone and allows us to see that layering of analysis layers happening. Now, one thing you'll notice here if we zoom in is that you'll see that, well, that's not being strictly adhered to. We're not seeing just yellow plants inside of this circle. We're seeing some white and blue and red plants still kind of filtering in. But again, as we were talking about with resolution of image and analysis, when we turn on the flower color layer, you'll notice that it's just pulling in inside of that zone the analysis points based on our site size that fall within that zone and adhering the plants only to those particular analysis points. So some of these zones might look like they're kind of like filling out square or have some really unusual shapes. And that's just based on which analysis points from our environment fall within that zone for including it in the flower color constraint.
Yeah,
Hopefully,
so this is definitely a small site. So
yes.
we would, we
So if
want
I
this to be small.
probably want this to be small, so I'll put small on, and you'll notice that it's filling out that circle more, and we're seeing fewer of those other types of plants that are different colors within this zone. And now we're getting something a little bit more strict happening here. The blue zone here, you're seeing no plants inside of here because the blue that we're using for this circle is not the same blue that we see with these plants. But we can play around with that a little bit, and I'll talk about that in the constraints tab here. Maybe I'll talk about that right now and sort of how you can modify the different analysis parameters. So, maybe you saw at the beginning when I briefly mentioned that if you scroll down in the constraints tab, you'll see that we have a selection of different other sub tabs here under the analysis info and parameters that allow us to change different values of those analysis layers and constraints that we're applying. In this case, with the sun exposure, we can change the location with longitude and latitude, time zone and location for the sun exposure that we're generating. But we can also change the growing season, the number of months in which we are actually relying on the planting to work. So if my growing season in Philly starts in March and ends in November, I want to make sure I specify that by placing in the numbers that apply to those months and then hitting the refresh button over here on the side. Because if we're only doing growing in the summer, that's going to be a lot more sun that's hitting our site in a particular way than if we're growing into the mid-spring and mid-fall. We're going to have a different type of sun vector that's hitting our site based on our location, given our growing months. So important to pay attention to those kind of details as well. Now the flower color, the soil moisture and the pollinator values, those are just have some descriptions talking about how we utilize those layers. But for the flower color, you'll notice that we have a slider here called sensitivity. And that is essentially allowing us to say, we have a specific color that we have assigned to this circle here for yellow. And if we open up our flower color layer here in our Rhino file, under the environmental layers, we have flower color. You'll see that we have a series of different flower color layers that we can insert in geometry for indicating what kind of zones we want to have specific colors. But we're giving it a specific RGB value to that particular color. And so if the flower color of the plant doesn't match the RGB value perfectly, then it's just not going to include it. And so the sensitivity allows us to say, give it a buffer. Give it a buffer of a range, in this case of 125, that allows it to reach beyond that specific color that we've indicated to colors that are kind of close to yellow or close to blue or close to red, maybe like a reddish pink or something. But in this case, our sensitivity is not wide enough to include this sort of baby blue that this plant has here. So let's say we jump it up to 200. Maybe that's enough. Yeah, looks like it's enough. We jump it up to 200, and now we're seeing some of these blue plants starting to come into that blue circle. The alternative is that we could actually change the color in our blue flower color to be a little bit closer to this baby blue that we're dealing with. Because when we increase the sensitivity, we're starting to get this sort of greenish color plant coming into our yellow zone, indicating that our sensitivity is now wide enough to reach from yellow towards the greens. So we don't really want that. I'm going to decrease it back down to 125, and maybe I'll just remove this blue flower color zone so that we're not dealing with the blue flower color restriction.
Yeah, we could also change the color of that blue, right? But let's for now. I'm just saying hypothetically we could change it to match. Yeah. And then if you move it a little bit, it refreshes that layer. So one thing I want to, Ben, I'm not sure what your next step is, but my thinking is that I want to explain something about the filling algorithm right now.
Yeah.
So you'll notice that basically it fills in a bunch of plants and then it removes plants that don't fit. Like that's how this particular fill algorithm works. But we have another algorithm that bases it off of a pattern of plants. So under the constraints tab, there's a plant layout style option, and you can either do fill planting area or pattern planting area. And pattern takes a pattern of points, and it could be any pattern, but we have some controls here for how to change that pattern. And what it does is it tries to fill every single point. And the only case where it doesn't fill it is if it can't, if that niche doesn't exist at all in any of the plants, right? So in this case, we're saying it must meet this blue color constraint and it doesn't, and therefore nothing fills in there, right? So yeah, for now we'll remove that. But I really prefer to work with the pattern planting area when I'm trying to kind of fill all of the niches, because what will happen is it will show you where you're asking it to do things that it can't do. You don't have a plant list that solves all of the things you're trying to solve. So you might introduce a new plant that has that blue that you want, or you might introduce that plant that has the, ability to be in wet soil and be in shade, or whatever the case may be. Um, but Ben, if you let's crank this up to and we say pavers. This is another thing we're going to change in the new version. We're just going to say pattern length or whatever. But I think we could do 1.5, and you can just double click on that little gray thing, and then you get 1.5. So we're going to effectively double the density of that, and um, it's it definitely takes a little bit longer, but you can really start to see that patterning occurring. Is there any, I think this is maybe a really good point to ask if anybody has any questions.
Chris or Ben, when you're changing the number in the spacing, you always have to hit enter, I see.
Yeah.
Yeah, so what you want to do, so it is a slider, but probably the better way is to double click on that gray toggle. This is one of the nice things about human UI, is that you can change that value manually. You double click, you put in the value, and you hit return. If you have a
That's just
light enough
one
setup,
thing.
if you have a light enough setup, you can move that slider, but it takes processing power, right? So we're not dealing with just like a line that has points on it. If you've seen Grasshopper scripts where people are just sliding that slider around, we're dealing with a lot of data. And what we want to do is kind of give it the value we're looking for, or take bigger chunks in terms of our steps. Sorry, Ishan, I didn't mean to interrupt.
It's just like, it's not like in Grasshopper where you can click out or you hit tab or something and it registers. It's just something that I'm just saying it out loud because I was running, like I was putting in the number and clicking out and it wasn't registering, and then I figured out that it has to be entered. So just something
Yeah.
to keep in mind if someone comes across that issue.
Yeah, we get, and this is one of the challenges with Ben and I, is we're so like comfortable with the environment that there are sometimes we forget to mention like little ticks that we do that are, we've discovered over time, and we just do without even thinking now. So um, that's part of why we interject and interrupt each other, because we realize like, oh, they're saying something that nobody knows what they're talking about at this point, because
Something inherent. Yeah.
we're like at this advanced level of
We
using the
appreciate it,
tools.
Sean, because we know that you have some familiarity with Grasshopper, and there's probably other people in this that also have familiarity with Grasshopper enough to be like, why isn't this working like Grasshopper works, even though it's kind of functioning from Grasshopper? Yeah, Human UI
Yeah,
is definitely trying to reach a group that is more comfortable with a rather traditional approach to how you input values and things like that. So the enter might make sense to most people, but for Grasshopper user, it might not at all.
yeah. I want to point out one other interesting thing. I mean, there might be a few other things we're missing here, Ben, but um, under I think it's under, is it under constraints or plants? I always forget. The packing.
Under constraints.
Yeah, so we can turn on what's called pack plants, and it didn't do a whole lot. We might need to make them a little bit denser in order to, or yeah, have a higher number of steps. Like maybe let's do 100 steps. Um, and what packing does is it does this. It might be also easier to see if we do the circular preview
Yeah.
of the plants.
So under the Out tab, like I mentioned early on, there is the output type. You can do a 3D option here, and the 3D
That might actually be better.
Yeah,
Yeah.
3D massing is the easiest just because everything is a sphere, so it's a little bit easier to see, or at least like some sort of oval. But in plan view, they all look like spheres, so it's easier to understand what's going on. But if I zoom in on the overlapping that you're seeing here between these plant radii, when I turn on pack, they shift out.
So maybe just give a big overview of that
Yeah.
now, zoom out.
So if you zoom out and you look at the plants now, it looks like that image that we've probably seen in a lot of like random little quick snapshot videos or something of things kind of like organizing away from overlapping with each other into sort of fitting into place, almost like when you dump a bunch of balls into a box, they kind of all like touch each other at their like edges and fill within that space. The packing is basically going to make it so that depending on the radius of the plant, and the shape and the size of the plant, they're going to shift away from each other into spaces to fill out the planting area, but also remove plants that are overlapping too much with others so that you have a nice clean look like this, where the
Yeah.
plants are all like kind of neatly touching each other's edges without overlapping much or at all.
Yeah. So Ben, yeah, that's great. I want to kind of talk to everyone. Oh yeah, that's good. Toggle it on and off. So this begs a question about like, what are we using this for? How far are we trying to take this before we are we trying to create construction documents? Are we trying to just are we at a SD level and we're just trying to kind of like get something beautiful for a rendering? And I think some of the things that we found are, first of all, this is a great exploration tool, right? It's a great tool for figuring out where different plants want to go, right? Even if you're like, okay, I don't care whether plants are missing or whether they're, look nice or whatever. I'm just using it as like a tool to figure out which plants want to go where so that I can get a sense and then I'll draw my zones and I'll make my mixes, right? So that's one way to use this tool. Another way is to do the next step and say, okay, I want this to look really good in a rendering. And this is kind of this is the nice mode here to do the pattern fill to make sure you're filling in all the areas. And then secondarily, to do the packing to make sure everything like looks like it's fitting together gorgeously and whatever, right? And you can adjust the density of that. Like we can see here that we have some plants that aren't kind of really quite filling together. And so what we might do is we might dial up the pattern density a little bit. No, not that. That's
Oh yeah, the
actually
pattern density,
that's
yeah.
the other fill. So maybe 1.7, um, something like that. And so yeah, so this might look really good in a rendering, right? And things aren't, it's not pushing the plants too far away from where they were being placed. Oh, that's even better. Yeah. So nice. Okay, so that's going to look good in a rendering. But is a contractor going to build this? Right? Are you going to be able to tell a contractor each one of these plants goes in this exact specific place? It's going to be challenging. And that's why we think if you effectively turn off the packing, you could have a pattern and you could show the contractor, hey, like we have a grid and these plants are going to go where we say they go, and that kind of works. The other way is to kind of dial back to where we started, which is to say, okay, I'm just using this to figure out where I'm going to draw those plant zones and what the plant mixes are, and then I'll provide the contractor with a hatch, right,
Chris,
of these zones.
does the pack plants override the pattern then?
The pack plants, it pushes the plants around. And so if they're pushing them too far, they could be outside of those niches that they're being placed into. That's the only danger of packing, right? Is if you're
But
packing too
is
far.
it like right now we have that hex grid? Is it overriding that grid?
Yes.
Yes.
Okay. All right.
Yeah. Yeah. So it overrides the grid. So if you turn that on, Ben, and zoom in a little bit and show them, that's maybe a little far, I feel like.
Let's go to the
Yeah, well, yeah, that's so it doesn't, it's not actually on the grid anymore. It's sort of, it's really all about filling the space and making it look like somebody, really drew all those circles and placed them nicely next to one another. What are we missing from the workflow, Ben? I think the one thing worth mentioning, since I'm talking about rendering and like doing something that looks really nice, let's look at this in 3D. And so all of these blocks are coming out in 3D. They're placed at the elevation that the plants are placed. If you want to bring these blocks, particularly into Lumion, we have a way to do that, which is under the Out tab. There's an export plants to DAE, and that will, when you click on that, you tell it where you want to put it, and it will export every single species as a group or as a file to separate DAE files. You have to tell it which parent layer. So all the plants are on this plants layer, right? So they're under that subcategory, and then you would say okay, and it goes through and it selects every single layer and exports each layer. And so now if we go to that DAE file, we have DAE is just like a 3D file format, right? But it's one that Lumion likes a lot. So if you open one of these files in Lumion, you can mass replace all of these little plant nodes with the plant of your choice, right? So you are going through, Lumion doesn't have a lot of great scripting opportunities. So this part, once you get into Lumion, is a little bit manual, but you're not placing individual plants. You're doing it's called mass replace, and it mass replaces a plant that you've chosen with a whole collection of plant nodes for that species. This can make rendering so fast. So you're not in Lumion moving plants around separately and then later having to turn that into some, redocument it into a design. You have everything here as blocks. Those blocks could go into CAD. Those blocks can go into Lumion. You can keep adapting the model. You can iterate, and it's a great way to do concept level planting. You have your own list. We also have an AI plant list generator, which effectively you just need an OpenAI key that you would plug in, and you can add to the list of plants. It takes longer to do this because you're effectively making a Chat GPT query or prompt, and it's giving you the answer, and it's basically turning that answer into plants for you, which is sort of what we've done magically under the hood. You can also load plant lists that maybe you or your colleagues have put together for a particular project or particular region, right? And this is where offices can kind of start cooking their own secret sauce.
Yeah, Sean.
Go ahead, Sean.
One of the, I don't, just because I know that there's a lot of content, but the enter plant constraint also, I think, is something that you guys have gone over in the past, where that is also good to show. I mean, one question I'm going to get ahead of that portion, and if I wanted to add a column, like, for example, I've done a lot of work in New York, in flood zones, and the way I usually work, I'm an architect, and then I did actually graduated from Penn with Ben, and one of the things that I wanted to learn at Penn that I didn't do a great job of is plants. So this is one of the reasons why the plant workshop is really exciting for me, because it spits out plants that, as Chris and Ben have mentioned, go in the right spot based on their solar desires. But in a lot of the contexts that we work in coastal climates, they have to be salt tolerant, and I think that this database doesn't have that as a column. And so what I usually end up doing is, New York has a really great resource of plants, salt tolerant plants, and I usually just reference that, and I start picking things and creating my own mix. But in addition to putting the plant constraint, which I think is a great thing that we've gone over in other workshops, could you create another column and that would be the plant? The title is the plant constraint.
Yeah. So
there's two big answers to that. Sorry, Ben.
No, you're good. Do you want to go through it, Chris?
Let me give the two big answers, and then I'll let you give the more detailed explanation. Yeah. So the two big answers are: one, this database actually does have salt tolerance.
Oh, it does have salt tolerance.
And you can enter that as another constraint. But the second answer is yes, you can absolutely add your own column that's like fuzziness or whatever, like you can add something and then constrain it in some way on your site, whether that's biological or ecological or design, right? Like it could be any kind of constraint that you're sort of creating or imagining or that, is part of common practice. So um, the way that let's just start by adding a new plant constraint based on something that's there. Ben, feel free to use whatever you're used to
Yeah,
using here.
I typically use fragrance is what I do.
Fragrance, yeah.
Example. That's usually a good, quick, easy one. And it's one that we already have in our little demo file here as a column with different values here. So you can see here in our demo file, we have a title here called fragrance. And so essentially what we would do is we can copy that title of the column, or we can just type it in over here in the enter plant constraint. So we want to make sure it's named according to the same as that column. And then we're going to hit the refresh button here over to the side to tell the software to include this as a constraint now. And when I do that, you'll notice that the schedule disappears. And that's because we don't have any values associated with fragrance input in as geometry yet for the software to interpret where fragrant plants are supposed to go or not. So now what we need to do is we need to give some geometry that indicates where do we want fragrant plants or non-fragrant plants. And so underneath here, we have a custom shape layer value. Under the environmental layers, we have a title layer called custom shape layer. We're going to select that layer and we're going to click the new sublayer button. And what that's going to do is it's going to add a sublayer underneath the custom shape layer that we're going to type in fragrant. We're going to name that new sublayer under that parent layer of custom shape layer fragrant. And the reason why we call it fragrant is because that is a value that we have associated with plants. We have a series of plants here that have a value titled fragrant. And so now any geometry or any location in our environment that falls within the zone that we're going to indicate as fragrant is going to make sure it searches that column titled fragrance down here in our workflow panel. And it's going to say associate that column with this name in this sublayer under custom shape layer to give us plants that are fragrant in that zone. So I'm going to make the fragrant layer my active layer, and I'm just going to draw a shape on my site that is the zone in which I want plants that are fragrant to be located. So maybe I want this zone inside of our little plaza area to have fragrant plants. As you walk into this zone, you can smell all these plants that are wonderful. So I created this zone, I added it to that fragrant layer, and now we see that the software is working again. And we can see we have this zone here. Nothing looks that much different, but that's because perhaps the plants in this layer or in this zone, there weren't that many plants that didn't have a fragrant value associated with them already. Maybe if we move this around a little bit, we'll see how it affects different plants being placed based on their fragrant value. So it's taking this zone and saying, because this zone, this closed curve that we've drawn is on the fragrant layer, and it's being associated with the column of fragrance, every plant inside of this zone should have a value of fragrant associated with it. And we can also add another layer called non-fragrant if we want. And again, we need to make sure that that matches the way it's written in the database. So it looks like we need to make sure that F is capitalized. Sometimes that can make a difference. And then now if we want specific zones with plants that are non-fragrant, we can draw a zone and it will affect those plants as well. And again, we might not be seeing very much difference because perhaps the plants are already sorting quite appropriately. This is something we're going to be updating. I'm not seeing a whole lot of change.
Yeah.
It's a little bit weird.
We want this to be this process. We have some ideas about how to make this process more robust so that you can add multiple layers and multiple constraints. But the big thing I think this also helps illustrate is that for like say flower color, it's the flower color layer, the parent layer, that holds all of the geometries that define where these constraints are happening, right? So the yellow, and if we draw on the yellow layer, that's where yellow plants will go. And I think the soil moisture has a similar thing where it's like soil moisture, and then there's dry, moist, wet, etc. And so you can draw shapes that correspond with these things on your, on your plan. And the neat thing is that instead of saying, oh, this plant needs to go here because it meets all these different criteria, instead you have a big site and you say, okay, I want red here, and I want wet plants here, and I want, this here, and I want that there. And you do these big moves, and then the script helps sort it all out for you, right? And the script starts to place all that stuff, and then you'll see, oh, actually there's no plants here because I've said I want it to be wet, and but it's also shady and I don't have that plant, right? And so it starts to tell you which plants you need in your list, and if your kind of your design assumptions and goals are meeting with the plant list that you're utilizing.
One thing that's
But
notable
yeah,
about oh, go ahead, Amanda. Sorry.
I just have a question. So, and this may be getting ahead of ourselves, but how do we then bake or save this wonderful information that we
yeah.
have generated?
There are two big things. One is saving your settings in the workflow, which is something that I think it saves every time you go to a different tab. But I might be thinking of something else, a different workflow we did. But if you say, you want to save your current settings, and that will save all of the settings you have. So the next time you open it, you just say load last save, and it will save that. So we highly recommend, I recommend always having, a version of the workflow for the particular project or piece of the project you're working on, right? And then you're saving that. But you can also save options. So you can say save a settings option, and then you give it a name up there at the top. So right now the default is option 1, but you could give it a different name like Ben. And you hit return, and it will save those options under load options. It should save
We
it.
made some updates to how we were processing that, and that didn't come through yet, Chris, but
Oh, okay.
yeah.
Um,
It's working with the
but
Topo and the paving workflow. So if you've utilized those at any point, those function perfectly with the
I
saving.
see. Yeah. So we're having a few issues with the save settings. If you're like, I need that updated, fix it for me. We can do that immediately, and we'll do that right after the workshop.
Yeah.
It was something I thought we had fixed. It's not a big deal. So pack plants, what else?
There's
Yeah, I
one thing
think
about this draw shape layer. So you're going to be seeing as we move forward through the workshop, a lot of different ways that you can create and modify and, do different things with these different environmental analysis layers. And two of the examples you're seeing here is the sun exposure, which is kind of inherent to the site. And we're using a set of components from a plugin called Ladybug that is a free open source environmental analysis set of tools. But the other approach that you're seeing here is the draw shape layer, where we're basically just in plan view, we're drawing shapes that indicate inside this zone, this analysis layer is being applied. And that is a very direct, easy, quick, efficient way of doing things. And you're going to see a lot of other ways that we can apply different environmental analysis layers. But notably with the draw shapes layer, you can, kind of speaking back to this idea of not having to kind of like have boundaries and edges that are meeting each other perfectly, because that takes a lot of time to say, well, I want this zone here to be, wet, but then I want this zone over here to be dry. And having that sort of organic boundary can be quite annoying to handle. And one thing that's really cool about the way that Chris built this is that you don't need to actually think about that. What you can do is that you can just draw a boundary that represents wet, and then you can also draw a boundary that represents dry that's overlapping with it. And basically what it will do is it will say whatever shape is smaller, that takes precedent over the shape that's bigger. And so if you look at what we've done with the soil moisture on our site here, we can see that we have two curves here that represent dry zones. Then we have no zones that represent wet. But if we look at the moist zone, we can see that we have a boundary that is encompassing the entire site for moist soils. So the dry soil zones are inside of the moist zones, but since they're smaller, those zones that we have indicated as dry will take precedent over the larger moist zone because it's analyzing the area and then giving you those values so that you can layer these things together without having to think about, oh, is this boundary touching perfectly or not? I don't want this to like, it's a bit annoying to kind of make boundaries meet perfectly. And if
Yeah,
you use the Topo tools, you kind of are familiar with that from the collage tool as well.
it's to try to keep things more intuitive in your workflow. So you can just say, okay, I know that most of the site is dry, and this area is wet. This area is moist. And then it's basically those small areas are gonna override the larger area, but effectively it's gonna fill. Yeah, I know we're explaining these things multiple ways, but we want to make sure everybody fully gets it, right? So I think we should take a 5 minute break. We're halfway through right now. I also want to propose that we may go over a little bit if for anybody who wants to go over. I think that we also don't that last file, Ben. I don't know how critical that is.
It's not totally
Um,
critical. A lot of the concepts in there are shared across other
yeah,
scripts or
yeah.
workshops. We might
And
skip that.
I think once we go through a few of these files, like once you really start to understand the bits and pieces, the other files are gonna like look a lot more familiar. And you'll start to hopefully that's the goal, is that you'll start to understand some of the approaches that we're taking with all these steps. So let's take 5.
One other thing really quick,
Oh, go ahead.
since we're recording this, if you do need to go right at the ending hour of the workshop, we're still going to continue on to finish out the concepts that we're trying to cover. So just keep that in mind if you end and we're still going and you have to leave. Just remember that you can come back through, watch the recording, and see some of those concepts maybe that were a little bit more detailed that you missed later. Anyway,
Yeah,
we always
awesome.
have these workshops because we always have too much content to share.
It's a lot. And we want to make sure, it also depends on the audience and the familiarity. If we had a bunch of people who were like, yeah, I've used this all the time, we'd be skipping through a lot of this a little bit faster. But this seems like an audience that we want to make sure we've got all the core concepts here. So let's take a break. Ben, I would just, if you don't mind, keep your screen up
Yeah.
for the recording, and then or I don't know, actually we want to make something different, so actually stop sharing. That would be better. And then everybody can just turn their video off, and we'll just keep recording that way. In the recording we'll be able to see it. Cool. All right, see you guys at 1:40 or whatever equivalent
Eastern
is
time.
for your time zone. Yeah,
Yeah. See you
talk
soon.
soon. Yeah.
Welcome back, Chris.
Hello. Ben, you're first, right?
I believe so, yes.
What do
Unless
we
you want to jumble up the order, but totally up to you.
And are we doing index drifts just like really quickly?
Yeah, I'm just going to do that very quickly at the bottom and just talk big picture about it, but I'm going to focus a little bit more on the species and color
Yeah.
first.
I also wouldn't spend a ton of time on species areas because I feel like, I don't know.
It's a little less.
Yeah.
Yeah. I feel like the index drift makes more sense in some cases than the species drift, just simply because of the option for creating mixes and stuff like that.
Right.
So I might just use the species area as a way to talk about the script and then jump down into the color drifts and index a little bit.
Awesome.
Or at least that was my plan. If I get bogged down, obviously let me know. You know how I get in these workshops.
Yeah, we want to, it's tricky because we want to make sure everybody kind of gets it, but yeah, we don't want to spend too much time on any given thing. It's kind of seeing everybody come back here.
Do we have everyone back now? Okay, we got
Awesome.
from Allegra, and there's Amanda. Okay, cool. It looks like everyone's back, maybe with the exception of the Outsa, but that's okay. He'll be able to join back in whenever he's ready. I have this file open, but I'll go ahead and talk through opening it as well so that you are prepared. Things are gonna get a little bit.
I think you might have paused sharing, possibly.
Yes. Yeah. So here's the unpaused sharing, and I'll open up my folder here. So the next file that we're going to be jumping into is wonderfully and neatly ordered as 0, 1, 2, 3, 4, 5. We're going to jump into now the 1_planting drifts file. So that is the Rhino file called 1_planting drifts. And then you will, once you have that completely open, you're going to drag the planting drifts, 1_planting drifts Grasshopper file into your Rhino window. and it's going to bring up the Grasshopper window, but it's not going to minimize it because, again, everything else from moving forward from here is going to be in the Grasshopper space. And we're going to be looking at things. We're going to be trying to understand what the script is doing, but also talking kind of big concepts too about what are the purpose of these different new components that we're seeing, these new functions, and how they can be utilized kind of big picture and focused in different ways for different planting ideas or approaches that you are taking on different projects. So when you open it, if you zoom out, you're going to see sort of 3 distinct zones of scripts that are happening in the Grasshopper file itself. But then also, if you zoom out in your Rhino file, you'll see sort of 3 associated zones that apply to each of those different ideas that we're going to be looking at. And each of these different ideas are approaching a similar concept in a slightly different way. The first one, we're going to be talking through the script a little bit, which is the species area. And then we'll be talking a little bit more big concept about the color drifts and index drifts as to how they apply to something you might do in the real world or in a real project. Again, Chris, feel free to chime in at any point, and feel free to try and follow along to what's going on. Look at the components, zoom in on them, ask questions about different aspects of the components that you're confused about. But also, if you want to just listen and watch, this is a great opportunity if you're the type of person who does better by just listening and watching and then going back and trying it out yourself. This is a great moment to kind of like listen and watch and just follow along without getting too bogged down with figuring out why things are breaking or not working. Sometimes that can throw you off and you miss really important concepts that can be useful for understanding. So I'm gonna zoom in now on our first topic under the planting drifts file. So I'm gonna zoom in here on the far left grouping and zoom in also in the Grasshopper script on these species areas. Now, you'll notice what I'm seeing here in the beginning of our script. You see this component that's turned red. You're probably seeing plants already in here, but that's because we're automatically baking blocks in and we've saved the file that way. It doesn't necessarily mean that the script is functioning properly because we have these plants pre-saved in the script or in the Rhino file. But if we zoom in at the beginning, we're going to kind of walk through what these different pieces of this script are doing and how they're coming together, and a rough concept of how this particular zone works, the species areas. So let's zoom in on this section called Import Plant List from CSV Zone and this component that has turned red. This is the component that represents that browse button that we were using in the workflow. This is how we're bringing in a CSV file into our Grasshopper script. You'll see here we have this component here, and these types of components are called containers. They allow us to filter in information in and out of the Grasshopper file, as well as apply direct information into the container itself. So in this case, this is a file path container. And all we're going to do is we're going to right-click this container right in the center where you see the C:/, or if you have the written out version, like this case, you'll see that it just says path on the middle of it. You just right click the part that says path. You'll go down to set one existing file. So down here, so right click center of the component where it says path or the icon, set one existing path. And you'll navigate now to your participant package. And we're going to start utilizing the ERA database here. So I'm going to scroll down to where I see the ERA database CSV, select it and hit open. And now what it's going to do is it's going to say, let's associate that specific CSV and the file path that goes to that CSV to this component, this container here. I'm going to switch back to the icons because I really like the icons. And then I have that file path plugged into the CSV file path input of our create plants from CSV component. I'm going to be doing this thing throughout the workshop, and Chris probably will as well, where I hold Control and Alt and select the component to show you where you can find that in the Land Kit tab. So you can see that this component can be found in the Data tab of the Land Kit tab. Now, what we have here associated with the Create Plants from CSV database is we actually have a panel here that has a list of plant species names. And we're bringing in a very specific set of species names, as you can see here, that we are indicating. We can also indicate the number of species we want to bring in, certain species, the column name for the species. So if you're using a different column identifier for the name of the plants that you're bringing in, such as common name or just name, then you can indicate that here and it will find that column with that name to create the species. We have random plants, or pulling plants in order from top to bottom. And then we also have the query input, which you'll see how we're using in some of the other examples as we go forward. We'll talk about that as we move into examples that are actually using the query. What we're doing is we're taking that and we're pulling in the plants. And the plants are coming from the CSV. And occasionally you'll see me double click the canvas here in Grasshopper and do a 2 forward slashes, which allows me to create a panel very quickly to show you kind of what's coming out of these components. And you'll notice here that what we have coming out of the create plants from CSV is LandKit specific plant data elements here, these different items here that represent a plant with a species name. And these plants have packaged inside of them lots of information about the plants that are coming from that CSV. We're taking that plant data that is unique to the LandKit tools, and we're pulling that across, and we're actually using a specific component that allows us to pull the plants out by name. This is applying a specific type of analysis to the plants. So I'll talk about that in a little bit more detail, but I want to talk about the other elements that we know about. So the two big concepts that we talked about in the workflow is we're pulling in our plant list, and then we're also creating our environment for our analysis to come in. And so we have our plants coming in from the CSV, and then we're also, as you can see here, directly, like very close to where we're creating our CSV and our plant list, we have our environment being created. And essentially what we're doing there is we're using the planting zone. So we're using a planting area that we have organized, I believe, in a specific layer, maybe not actually in a specific layer. Looks like it's just in the default layer. We've assigned our planting area as this rectangle here into this particular curve component. So this is just our planting area coming in as a curve. And we're just converting that into a mesh really quickly. And what that allows us to do is it creates a very flat topography that doesn't have any specific defining topography to it. And we're inserting that into the create environment. The create environment component needs a boundary, so the rectangle of our area that we're planting within, and a topography, which we're creating using that planting area. If we had an actual topography like we had in the planting workflow, we could input that in here. And then we also have a cell size. The cell size is the reference we were talking about with the site size, where we're indicating the spacing of the analysis points for our environmental analysis. In this case, we're giving it a cell size of 1, indicating that the environmental analysis is a grid of points that are 1 foot by 1 foot, because our units in Rhino are set to feet. If you were in meters and you opened up this file, it would create a grid of 1 meter by 1 meter cells. That environment is just a package of information called the environment. You can't really see from just plugging this in what's inside of that environment. You'd have to use another set of components to interpret that. But we're not adding any other environmental analysis information to this particular setup here. We're just creating our environment, and we're pulling it in to apply to our filling areas with pattern or filling areas with just planting. So we have our environment that we've created here, and we have our plant list that we're bringing in here. Now we're taking that boundary and we're pulling it up into this zone up here to create an area, a LandKit area. And this is an undefined area. Create a panel so you can see that. Again, just a package of information that is a LandKit area that we are then using to create a pattern. And so the pattern, if you've used any of the paving or patterning tools, you might be familiar with the add pattern to area, which you'll maybe see a lot of familiar inputs from when we were looking at the settings for the add pattern to area in the workflow, where we can change the different pattern types. We can change the length and the width of our different pattern pavers, if you will, or spacings. And then there's other few input options here that if you want to play around with them a little bit, such as seam spacing or rotation of that pattern, that you can actually modify as well. And then what comes out is the area with that information embedded inside of it. as well as the pavers themselves. So if I were to preview what these look like, we can see that we're creating a hex grid here across our site, and then we're isolating that hex grid's center points to generate the pattern upon which our plants would be placed. Now you'll notice that the plants are not being placed perfectly on that pattern because we're not utilizing that pattern planting right now. We're utilizing the fill planting areas. So you'll be able to see that alignment happen once we test out the pattern planting.
This is just you'll see this in some of the scripts. It's an option. So this is right now, this is kind of a non sequitur. Hang on a second. It's a non sequitur because it didn't go anywhere. But if you plug in that into the, kind of where this was going, right now we see that it follows that grid, right? So it's an option to do either a pattern fill or kind of a more organic fill. And we approach each of these a little bit differently, and we'll talk about that in just a moment.
And if we don't talk about something that is kind of it seems like we're just kind of making an assumption about for knowledge, obviously drop a comment into the chat or chime in and say like, hey, like you've talked about this a lot, but I don't understand what's going on here. That can happen because there's a lot of information happening here.
Yeah, Ben, can I also just zoom out for a second, because I feel like we jumped right into details, and I just want to give the team
good call.
Like it helps, even if it's in the middle of the process, I think. So let's just look at what we have here. Can we zoom out to that a little bit? We're basically, this first tool we're showing you is just like a scatter fill tool, right? Like each zone is on a layer with a species name, and we're trying to fill that zone with a species plant, right? There's a few challenges to that. One is that some species are smaller than others, right? So if we do a pattern, they're not going to fill in properly. They're not really going to sort of fill the space. They're going to sort of be spaced out. So that's a challenge with using the pattern. So that's one option, but we have this other option that probably is the one we'll show first. And let me just review what we've looked at so far and kind of where we're going. So we start by getting a list of plants by importing them from the CSV. We are going to bring in all the shapes that we've drawn on these species layers, and then we're going to do a few like little funny steps to kind of make it all work, but effectively that's going to end up coming together and filling plants into those areas. In here, sorry, filling them into that area. Now, we don't need a pattern if we're using this guy, right? So and we also don't need that extra like zone. Effectively, we're creating a whole zone that has one big pattern across it whenever we do this. So we create a zone and then we add a pattern. Sorry, I know it's like getting messy here. So the trick though is how do we get a denser amount of purple versus like this white, right? Like how do we get the density that's correct for each plant? Well, this is a little portion of the script that we do that with. Okay.
Chris?
What's the question? Yeah.
Question is, so you essentially have blocks of the plants of different plant sizes, and you built those as blocks in Rhino?
That's a good question. So, no, we actually have generated all of these, every single plant in our bake plant block tool or preview plants it's generated algorithmically. So it depends on the name. The name is actually the random seed. So
Okay.
if we zoom in here, Ben.
Yeah. So no, if that's part of the process, then that's great, and we'll get to it, but you don't necessarily have to zoom into that yet. But I was thinking maybe that was already built in, and but it sounds like it's part of the whole
it's kind of built
the whole
in. Yeah,
environment.
and it is part of the environment. But basically right now we're doing a style of 4. But if we did like
Okay.
a style of 3, we have a few different styles for these. So you can see that immediately it updates the plant style. And then we could do like a 1, and that's a different style. And then there's the ability to have a 0 as just circles.
Okay.
And so there's different styles. Immediately it's creating a block, and we can later,
Right.
like if you're like, hey, I want to use these particular blocks,
Right.
there's a few ways to do that. One is there is a way to do it in the script. It's a little bit more tricky,
Sure.
so that it just spits it out. But if you're doing a lot, it might be worth it.
Right.
Or
But in
you
this
can just
case,
select them and do a block replacement in CAD after
okay.
the fact.
Right. But in this case, it's basically by how you've set it up, it's recognizing um, it's recognizing the plant size from the database. Is
Yeah,
that correct? Okay,
exactly. Yeah.
great.
And when we do we can do an 11 as well. I don't know. Yeah. And that is actually creating a 3D block. For each plant. And so it not only does it have the radius, but it also has the height of the plant. Right. So it gives us a bunch of different options here to display that.
Okay, thank you. That's helpful.
Yeah, absolutely.
I think one thing that we didn't talk about before, Chris, when talking about what blocks allow you to do as well, that I think is kind of important, is a lot of people use other software like Land Effects for creating their documentation. And I know probably a lot of you here have used Land Effects as well. The block forms and the way the geometry is created here in the outputs from the Land Kit tools create a block that when you import it into or export it from here and into a DWG AutoCAD file will allow you to do mass replace on each of these blocks with Land Effects plants as well. So it's not just something that you have to utilize for rendering with Lumion with mass replacing, but you can also take that into some of the more commonly known documentation tools like Land Effects and do mass replacements as well, so that you don't have to figure out how to make documentation out of just the sort of blocks that we've created here. You can use some of those other software that have really robust tools for documentation as well. Anyway, continue, Chris. I'll zoom back out. You're muted. Sorry.
I think it's worth getting back into this. So let's just if you don't mind, Ben, I'll talk through these kind of
Yeah,
weird
absolutely.
fiddly parts. So in this gray area, if you could just zoom in. Yeah. So what we're doing here is this pulls all these areas, all the geometry from these sub layers, right? So it's automatically pulling them. And then we're using this component to get the layer and the color name, the layer name and the color. And we use that to create areas, right? So we have for each thing, we have geometry, we have a layer, and we have our color. That creates all of our different zones. So we have the white zone and the green zone. But they're also, if you look at them, they're named after the species, right? They're actually associated with each species. When we use these little panel components, it allows us to sort of preview what's inside of any given output, right? And we like to use this a lot to just see what's coming out. Why is this turning orange? Well, let's see what's going into it. Let's just check from the component before, etc. So so I have each name, and if I go up here, what we're doing is we have a list of plants, and then we have these names, and you see the dotted line. The dotted line means that it's a grafted tree. Yeah, thank you, Ben. So we have a branch for each thing, and each branch has one data item. And this is important because if you don't understand Grasshopper data structures yet, we're not gonna be able to kind of explain all of that in this workshop, but effectively, it's like, let's say you have a list, right? And this is like one this is the trunk, right? And it's just one list, but we want to grow that tree, and we can say, all right, for every single data item, let's put each one on a branch, right? So now we have a list of one on each branch of data. The cool thing about that is we can do a bunch of stuff within each of those branches as we move through the Grasshopper script. And then we can, if we have another branch, we can kind of merge those like this and say, okay, only do this stuff to this branch, right? And match them. Or eventually, once you've done all this work, bring it all back together, flatten that back down into a trunk, one branch, right? So that's kind of cool. So what we've done is we've made a list. We have our list of plants, and then we say, based on the area type, grab that plant for that area. And that allows us to see we have a branch full of plants, a bunch of branches that each one has a plant. And then if we go over here to where we're filling, what we have is we have each area on a branch and each plant list on a branch, which was just one plant, right? So it does filling of each area separately, right? So it's the plant and the area coming together to have that, kind of peanut butter and chocolate phenomenon for each one. The other thing that we're doing here for each area is we get the plant, and we're pulling data. We're getting the current plant data. What we do is we say that we want the radius maximum, a radius max attribute key, and then it gives us the maximum radius that's in the plant data for each plant. And we're remapping those into into spacing for our well, not spacing, sorry, into like some sort of a packing ratio. And so what we've done is we've said, okay, let's actually, Ben, can you plug in the bounds into one of these?
Yes.
So the current, range of plant max, radius is from, 3 inches or a quarter foot to, 1.8 feet. So this is our larger plant here, 1.8 feet, and then this is our smaller plant here. And for each one, we're going to remap each value. 0.25 is going to map to 0.3, and 0.18 is going to map to 1.5. So it's actually pretty similar in terms of the density that we're talking about, how dense we want it to pack those plants. If I'm not mistaken, I think that's right.
Yeah, that looks right.
Yeah. So we basically map what the plant radius is to a new packing ratio. So,
and you can see that directly right here, where the value of the first radius of the plant here at the top is 1.8, which is our higher value. And when it comes out of the remapped numbers, it's 1.5. So you can see that.
So the reason all this is important is it shows how in Grasshopper we can use LandKit, right? We can use these components to like get our plants, to get our environment, to create an area, and then to fill plants into that area. But we're doing something kind of, this is why this is the advanced workshop. We're doing something where we're saying at the outset, we say, break this into these kind of branches so that you have all the plants on different branches. You have all your areas on different branches. You even, in this case, you have a different parameter for each one of these on a different branch. We're doing all of that in one flow. That's the cool thing. That's why the branching data is so interesting, because we're flowing all that data through one structure. A lot of people will say, oh man, for each one of these zones, I have to copy all this stuff. And they'll copy it, and they'll make a copy of that for every single species. And then if the species change, they've got to add more or remove some or whatever. And it's a lot of script that they don't need. And so what this does is this might seem a little technical right here, right? Like it's sort of saying, okay, grab a piece of data, right? Grab an attribute, which is the radius, and then remap that radius to a new range. But that allows us to control how dense these are planted for each plant type, right? And then after that, we're doing some plant packing. So if I were to like skip the plant pack, oh yeah, Ben's kind of messing with the parameters here. If I were to skip that plant packing, I can see that the plant packing isn't going to really affect my little plants very much because they still are spaced enough. But with these bigger plants, they need, that they're going to stick out more if they're not packed nicely. And so this is one of the reasons why we pack them. We have a little bit more density with the packing ratio. So, and then when we do the packing, they kind of fit in a little bit better. Anyway, I know that's a slightly challenging first script to look at, but let's just review it again real quick. Just so actually, Ben, can you go full screen with the
Yes,
script?
absolutely.
Yeah, there we go. So we can see all the parts and everything. So again, we're getting a plant CSV file that we link to that CSV. We have a list of plants, which is going to correspond with our layer names for the different zones that we're drawing. Those zones will be brought in automatically. Another way that we could do this is we could bring those in and then we could plug this into here, actually. So that would be another way to like avoid having this list. And if you had all those, I'm not sure we necessarily want to do this, Ben.
Yeah, I'm going to hold off, but at least you can see the fact that when we pull in the species name, layer name here, we have
Yeah.
this option.
Yeah, we are actually, so yeah, this is what this does. This is actually removing this part of the layer name, the sort of parent part of the layer. Then
Yeah, sorry.
so,
You're good.
it removes the parent part of the layer name, and then we get the species. Now I feel like we have a mess here.
The
Can
key
we
is
just
that if you do that, here, I'll strip this around so it's a little bit easier to see because there's a lot of, I'm going to delete some of these panels.
cool.
Yeah, so the manual nature of just inputting a list of different plants that we're bringing in from our CSV file can be avoided by just taking this output here and plugging it into the names. And if you did that, then if you wanted to change which species goes in each area, all you have to do is change the layer name over here. You match this layer name to the species you want that layer, and it will
Yeah,
automatically update for you.
it would allow you to skip this step. And that's something, it's like every time you look at a script, you go, oh, well, we could have done that a little bit differently. Even for us who've, we built this and we're like, okay, what's the best way to do this? If you go full screen one more time, Ben, the one thing you would want to do here is you might, actually, we could keep this grafted probably. You want to just hit save and plug that in, Ben. Let's see how it works.
This right here into there?
Yeah. Mhm. It's not liking it. What did we do?
It likes this version. Yeah.
Did I tell you the wrong? Yeah, this is the actual area. We want the name. Okay, cool. So yes, it's a matter of paying attention to what is coming out of any given output. So this is text coming out. This is actually an area coming out, right? And I told Ben to plug the area in. And then this last piece, as we mentioned, we have our area data, and we can plug the area data directly into this bake plants. We can give it a parent layer to bake everything into. And then we like to we like to say that overwrite is true, so that every time you make a change, it overwrites the stuff that you've already baked, and that it's also baking. True means that it's always going to happen every time any of the any of the inputs change. And that's just going to put those plants whatever their elevation is. In this case, we have a flat topography, right? We did that just because we need some kind of environment to get started. And then here we're doing a plant schedule. And I don't know if we showed the plant schedule.
It's not currently being shown, I don't think, on this one. Yes, it is.
There it is. So this shows how easy it is to basically just, if we look here, how easy it is to plug in, zoom in a touch, to plug in, our plant area. Oh yeah, plant areas. And we're plugging in plant areas, and then we have, whatever style. I like to keep the style, we're using the same style for both of these things so that we don't get confused. And then we can show the niches, which if right now we're not actually showing any niches, but we'll show you how that looks. But that's if you're doing sunshade or whatever, it'll actually show you what the niche is for each plant in that schedule. And all the data for that schedule comes out of here. And we have the text list and the text locations, and then we build text here. So that builds all the text values. And then we have our symbols and our colors, and those are located and those get previewed here. So pretty fun, pretty simple though at this point. So let's start talking about how we can actually add at least one rule for placement of plants. And that's the next demo, which is this
Color drifts.
Yeah.
So
color drifts.
Color drifts. So this is the general layout of the script that you're seeing that we've talked through up here is going to be the same for all three of these. There just might be one or two little additives into it that we're going through. So we're really only going to talk through in this particular script, the drift script, about the things that are different between the next two sets, so that we're not rehashing some of the same stuff that we've talked about. But in general, you're seeing importing plants from a list, creating an environment, creating an area with a pattern, filling those plants into the area, and then baking out those plants. And for those of you who aren't as familiar with Grasshopper, every time we say the word bake, we're just simply saying that the geometry inside of Grasshopper isn't physical geometry in the Rhino file until you do an action called baking. And so when you bake something from Grasshopper, it becomes a piece of geometry in Rhino that you can select and then use or export or anything else. So you're seeing here a very particular pattern based on the color of the plants. And what we're doing is we're using a similar concept from what we were doing above with kind of organizing plants into different areas on our sites based on certain types of categories of zones, but we're doing it using an image. So let's talk about that environmental analysis layer we're adding in and how it's pulling that information in. So if we zoom in here on our create environment part of our script, so again, we're down here now in the color drifts section. It's going to look very similar to the species area. And then we're just zooming in on the blue zone here where we're creating an environment. And then also you can see here adding an image layer. So we have our environment again with our cell size, which we've made a little bit more detailed at a 0.5 cell spacing, with our boundary and our topo just represented as a flat piece of topography. And then we're filtering that environmental package through an image layer. And what we have here is we have a BREP that's coming in, which is basically a form of a surface. It's a type of surface that's a boundary representation. It's just a type of geometry that you see in Rhino. For most people, a surface is the best way to describe a BREP, but it is a little bit different. And that BREP that we've inserted is coming from a particular image that we have inserted into the file. So if you turn on under the image patterns layer, the sublayer color, you can see that we have this kind of cool image that kind of looks like the cells in a human body, or maybe some kind of cells in a plant of some sort. And if you look at how it's overlapping with our site here, you can see that the plant flower colors are following a pattern that matches the image underlying. And so if we move this image around, it's going to change the location of these flower colors and the plants with the particular flower colors to match the underlying color variation in that image. So we turn this off and on, you can see that the greens are kind of matching some of the greens, and the yellows and are matching some of the yellows, and the purples are matching some of the blues. Yeah, pretty cool. So how is this actually working? So we've taken that environment and we're adding an environment layer to it, the image layer. And we're bringing in that environment. We're naming this new image layer as flower color, so that what it does is it says, oh, this title flower color is associated with this image. And we actually have that flower color data inside of the plant, so that when the plant database comes into our file, and I'll show you how we're bringing that in just a second, it's going to associate the column in the CSV database that's titled flower color to this image layer automatically. And then we're giving the BREP input. So we've selected this surface here that has an image associated with it, and we've right-clicked the BREP layer and done set one BREP, so that that image is being associated with the Grasshopper script that is then plugged into the picture input. And then we've given it a channel, which allows us to filter between red, green, blue, and all colors to create different interpretations of that image in different sort of color channels. Sometimes this can work really well with certain other usages in black and white as well, but we can experiment with that, and you can see that later too. And then over here, we're taking that environment, we're plugging it into the draw layers mesh, which is just a way to preview what's happening here. So let me turn off these plants really quick. And you can see that the draw layer as mesh allows us to see that image that we've placed in the site that has been reinterpreted by the LandKit tools and then redrawn as a mesh that is previewing that analysis layer. So if we turn on this image, you can see it looks almost identical. But that image that we're previewing out of the LandKit tools might be more fuzzy if we were to change our cell size, because the image that we're seeing here is going to relate to the level of detail of analysis that we're performing. So right now it looks almost identical to that image, but if we were to increase or decrease our cell size, we might see a variation in the resolution between our underlying initial image and the previewing of that analysis layer as it's being processed by the LandKit tools. Okay, so we're taking that output from the image layer and we're just bringing it directly into the fill area with pattern, planting. And so that image layer is now applied as a part of that environment package. So now how do we apply the plants themselves? I'll turn them back on. How do we apply that flower color association directly to the plants themselves? If we go down here to where we're importing our plant CSV, we're doing two different things here. So this is the first time that we're being introduced to the idea of a query. So we have here some ways that we're filtering the plants that are coming into the CSV. That's where when we were talking about checking on and off herbaceous and trees and shrubs and grasses as options to come in, or choosing the state in which our plants are native to. That's what the query is doing, is it allows us to choose any constraint or characteristic of a plant and say whether or not we want to filter our overarching database based on that particular query or that particular column. So in the case that Ishan mentioned before, when you're dealing with plants on sites that have a lot of considerations related to salt tolerance, this would be a place where you could actually add a column here and say, well, I want to actually include only plants from my database that have a high salt tolerance. And you could actually filter your whole database based on just salt tolerance, or based on a variety of different characteristics. In this case, we're using the distribution USA column, which is where plants are native to. And we're actually saying only pull in plants. So we have a true value here. So we have the fields as distribution USA as the first one. We're saying make sure the plants are native to CO, Colorado. And then the first input is true. So it's saying only bring in plants that are native to Colorado. And then what we're doing is we're saying find the plant type column, find plants that have an association in that column as tree or vine, and don't include them in this plant list. So now we know that all the plants coming in from our import from CSV are only going to be plants native to Colorado that are not trees or vines. And we're bringing in roughly 49 of these plants that are randomly being chosen from that database.
Yeah. So before we move to the next step, I just want to talk about this big idea of, we have, when we're picking plants and where they go, this is picking whether they go on our site at all, right? Right. This is sorting it out and saying, okay, we're in Colorado. I only need Colorado plants, like for example, or we're on the ground. I don't need trees. I don't want vines, right? Like these are the plants that I want. Or you could say, this is going to require all salt tolerant plants, hands down, or this is going to require all sun loving plants. So you can filter that way before you even start placing plants. But then once you get to an area, it's like whether a plant wants to be here or here, depending on its niche. That's where we start applying those rules, and we'll be looking at those here as we go. But I know we are pretty behind here. I'll
Yeah,
just
I'll
say.
kind of speed up a little bit. That way we can kind of get through this a little bit faster, talk a little bit more broadly. This is basically just a simple way of taking those plants that are coming out and saying, we only want plants that have flower color values. And so we're really trying to disclude plants that don't have a flower color associated with them in that database as we looked at earlier. So we're just filtering down the plant list so we can be sure that all the plants we're using have flower colors associated with them. And then the next step is with any type of characteristic, or in this case, niches that we're using for these plants. Niches kind of goes sort of hand in hand with this idea of a plant characteristic, is we need to apply that plant characteristic to the data that's coming in. So we can say there are certain characteristics that automatically come in, such as the flower color, or I mean the radius and the height of the plant and the species name and things like that. But things like flower color and the sun exposure preferences, you need to tell LandKit, bring that information and store it inside of the plant so it can be utilized for placing the plant. And that's essentially what we're doing here is we're saying, find the flower color volume column in the database and apply it to the plant. And then right here, what we're doing is we're giving it a buffer, that sensitivity slider that we were talking about in the workflow, and saying, not every plant is exactly green or exactly purple by RGB value. So give it a cushion right here, or a buffer range of that RGB value. And then what we're doing is we're saying, take that list of plants and merge that information together. So we're making a change to the plant by modifying the niche value, that flower color value, to include a cushion of 180. And then we're updating the plant list to include that modification that we've made with the merge plant niche. The next thing we're doing is we're taking that modified plant list where we included that cushion, we're plugging it into the fill plant areas, and then it's taking that name, flower color, that is the same as the association that we've tied to the image up here, and just relating them. It's just saying, take the RGB value of the flower color with that cushion, see if it fits here. And that's the reason why you see that the purple is fitting within the blue zone, because the cushion of 180 is saying, find the color blue on the image and go into a buffer range of 180 on either end of that blue value to find a color that is close enough to blue to fit. And purple is fairly close to blue, as we probably all know, or hopefully all know. And then again, we're just baking that out, and you're actually seeing that example that Chris was saying about being able to preview in the plant schedule the niche value. And down here in our plant schedule, you can see that in addition to having the species name, the symbol, and the number of that species that's being planted, we have the flower color of that species and how much of a buffer that we've assigned to it based on that cushion value that we've assigned. Yeah.
So a really fun thing just to see how to illustrate this buffer, etc. Just zoom out a little bit, Ben, on the Grasshopper, and then make those two preview visible. So what I did is I mapped out the colors, and that's what this little script is. And so it takes the color from the image and it kind of maps that in space. And then it also maps the colors of each species. So like these are the species that we had to work with, right? But then these were the colors from that image. And so that radius of 180 is sort of like I actually literally I did this little script, and then I was looking. I'm not saying you guys would necessarily do that, but I think it gives you the sense of like how, we go from 0 to 255 in each channel in each dimension RGB, and then colors get mapped in that space, and then we're the cushion that we're talking about is really that distance between color and color space, right? And so that's just a fun thing to add to this one.
And I think something that's really cool and unique about this is that, you could take a sketch from a client, a colleague, a boss, and if they've just sort of like kind of sketched out with colors on a marker on a piece of paper and you scan that in as color, or maybe you drew it in Photoshop, you could just take that Photoshop JPEG or PNG, bring it into Rhino, put it over your site, scale it, move it around, change it however you want to get sort of a look and feel. And so it creates this more fluid process where the plants are being placed properly, but as you're making changes or edits or iterating through the idea that's underlying, you already have the setup for the flower color ready to go, so that no matter what changes you make, it's automatically updating for you every single time. And you don't have to do that step in the process every single time where you're like making changes and trying to figure out what plants go where with color. So
Dan, do you mind if I do the overview of this next one?
yes, I was going to ask you
just
if you
to
wanted to. Yes.
Yeah, let's look at the matrix. So turn on that image, D for drift. So we're doing a similar thing here where we take an image, and it could be any. I just picked this because it was an interesting pattern. It had a lot of colors. But like we could scale this, like Ben, just scale that up like 2x or like whatever, just make it, yeah, there you go. And so when we scale that image, it actually scales the pattern filling. We can turn it off now because I think people get the idea. So there are zones that don't have any plants, but uh-oh, I've got my friend is joining me here in a second. My son is coming up the stairs. So we have what we're doing here is we're saying for each one of these colors, try to break it down into different mixes, and we can actually make a mix for any given zone. And I think we're using pseudo plants here, and pseudo plants, it's similar to CSV, but it's just kind of randomized plants, right? Plants with random parameters. And the neat thing about pseudo plants is it allows us to fill plants in that have the characteristics we're looking for. And then once we have that, we can say, hey, like what would replace this nicely, like after the fact. So if we don't know, so it changes the order of the process a little bit, but in some cases, this is what we need, right? We need to just start where I don't know what the plant, somebody else is working on the plant list. I'm going to start working on the design, and how this thing is going to lay out and some other things. So it allows us to kind of work asynchronously. But let's zoom in on how we're creating the list. I think that's somewhere in here.
This is where
so
yeah, it's kind of
yeah,
in zone in general. Yeah.
it's kind of a weird thing. So what we do is we have some plants, and then based on the number of plants, we make a series of random numbers. And then we say that based on the color drifts that we're also simplifying that color drift layer using a layer formula, which I can talk about more. And we basically match a random number to to each of those zones that have been simplified, right? So it's a pretty random approach, and it's less specific than the last one, but it just shows you that you can control these things in this way. Let's zoom in on this really quickly. The formula, Ben.
Yes.
This is like, I would say, a very advanced feature. But if you have an environment that has a layer, in this case, the image layer that we've added, and Ben, can you extend this panel out so we just have one line?
Yes.
It'll be easier. Okay. So you can do basically and it's amazing what you could do with ChatGPT here to ask it, make me a one-line code in Python that describes X thing. But you can basically create a new layer called drift by multiplying whatever the image value was by 6, and then making it an integer, right? And then now I have a new layer called drifts that has these indexes based on that original color, but it's simplified. Again, I don't want to spend a lot of time on this because most people are probably just going to be like, what are we doing? But if we go, let's go over to where these are being placed. And yeah, I think that's probably as far as we want to go on the index. I just think it's an interesting thing.
One thing I
You
think
could,
that, yeah, one
sorry,
thing that
just
I think it applies really. Oh, go ahead, Chris. Finish up what your thought is. Yeah,
okay.
sorry.
I'm sorry, Ben.
No, you're
If we
good.
could just randomize the pseudo plants real quick, just to show that, the neat thing about having procedurally generated plants is you can just update and get new iterations, and you could say, oh, hey, that's actually a great idea. What if we had these big red zones? And it's just a way of generating ideas, right? And saying, oh yeah, and then this could be like some sort of pollinator pathway or whatever. And maybe then you're onto another script, or you're onto another idea, and using an image to drive this in another way or something. But a script like this could help you generate ideas, or generate, say, hey, what if we had more of it like a zigzaggy thing? And then you just go and find an image of a zigzaggy thing and plug that in, right? And it could be grayscale, it could be whatever. Cool. Ben, did you have any other thoughts on this particular?
I think the thought, and this is something that we've heard from a lot of people who are asking about the planting tools, is how can we create zones with different mixes and play around with that? And I think the application of this is ready, because while what Chris was talking about here is we're giving each plant a random value for their association with these drift zones related to that image. But as we talked about with the ERA or any custom database, is you can create your own column here. And if you create your own column and you title that column drifts to match the data that we're seeing and creating using this image, this layer by formula, you could then say, okay, well, all of these specific species of plants here are a part of the same mix of plants, and let's give those a value of 1. And then we could start to insert in and say, like, all of our sort of meadow grasses have a value of 2, and all of our herbaceous plants that love moist soils have a value of 3 or something. And then what you do is that when you start to add in an image layer or create zones that have specific values associated with them, it's going to search that plant list for that drifts column and say, take that value of 1 now and put it into this zone because it's associated with that drift zone that you've created manually. And you could even have, like you're seeing here with our species that we're previewing the drift values, they could have multiple values. It could be a value of 1 through 5, and then that specific species fits into 5 different mixes. And then you could have the database itself automatically creating your mixes for you that you've specified, and then placing them in the zones based on these different images or boundaries that you're creating that are associated with that particular drift analysis layer that you've created manually.
Ben, you just did 2 things there. One was like a super direct way that people can work, which is to add these like values directly to their database, which I think is an incredible addition to this conversation about how, like, why would you think it this way? but then you also just like went and like just showed like all these different possibilities of like you could actually different plants could also have multiple drifts
Yeah.
associated with them, which I think is really fascinating. So that's just like a way to, you know, show you guys different possibilities. This is a little bit less orthodox and less um, familiar way than we generally think or work, but we thought that it was a great thing to include for this workshop. All right, so let me switch gears unless there's any other thoughts on this for this next piece. So there's the card. So this next script is called Affinity, planting Affinity, and I always think of Kevin Finnerty, if anybody knows who that is. It's it's Tony Soprano when he's like in his weird dream state when he's in his like coma. Um, so what we're doing here is it's a lot different than using an image as a rule. In fact, we don't even have any rules for like an environment. As you can see here, the environment piece is very light. So I've tried to color code. Drawing on the screen is harder when I'm using my.
I can
Sorry.
help for you, Chris, if you want.
Yeah, can you draw? So you can see the environment part is like way smaller. We're not like doing any analysis layers. We just all we're doing is defining an environment. And then what we do is we spend more time on this long trail of getting our plants to have all the parameters and et cetera that we want them to have. And then and we fill, so we have two fill steps. So the dark green is one fill step, and then the light green is another fill step. And that first dark green fill step, and yeah, exactly. That first one is actually based on different plants being associated with one another. So if you're thinking about companion planting, this will illustrate to you how you can like associate this plant with this plant. But the planting tools here also allow you to make all these kind of like a whole chain of associations, which is pretty wild. And so Ben, you can clear that. And then once so if I were to just show you what's happening with this first list, this will make it easier. So if I just do that, you can see that we have actually very few plants being filled in here. What I've done is I've pulled some plants from a CSV using similar parameters that we had in Ben's last script. So distribution is Colorado, and we're not doing trees and vines. We can have shrubs, we can have herbaceous. And then we remove the plants that don't have colors. We do that for the demos. And also, if you think about it, the plants in this database that don't have color are probably the plants that don't have as much data associated or maybe aren't used for commercial use and are probably less likely to have that data available. So once we have those plants, we're going to change the weight of each plant. We're going to get the length of the list, and then we're going to create a series of numbers based on that. And we can say, what's the starting value and how much of a step are we going to have for each one? And then we can attribute each of those as the W value. And the W value of each plant is its weight, right? So if I want, one plant for every two plants, the weight would be 1 to 2 or 1/2 to 1, right? Like it doesn't matter. You don't have to get exact percentages. It's just based on like cooking, right? So if you double the amount of space, it'll automatically double the recipe for you, right? And so you can associate. And so this is just a way of showing you, first of all, that you can associate W values. You could also do this in a column in in your plant data, a W value. And then there's the idea of creating affinities. So for each plant, I'm going to shift the list. So I have a list of plants, and I'm going to take that list and say, go like this, right? And what we're going to do is we're going to associate plant 1 with plant 2, plant 2 with plant 3, et cetera, et cetera. So we shift those and we say, create a new niche. And for each, let me use a panel here. So we have our plants. And then we're going to have another list. And we're going to have that shifted list. So for, geranium's going to be associated with eustoma, sorry. And then we're going to have a domain of 4 feet. Watch what happens when I have a domain of 10 feet. Let me just demonstrate. So if I have a domain of 10 feet, it should make our scattering bigger, right? So what this does is it constrains plants and says, hey, if you're not within 10 feet once it's placed, remove it. But the cool thing is you can see that if I zoom out here, what was our first plant? It's this. It's actually the first plant is going to be the last one, Astoris. So this, well, the thing you have to understand is that it's basically going to, it's going to actually place the beginning of the chain first. And then wherever that is, it'll place the other plants around that. So you can create automatic companion planting this way, right? And you could do that within a spreadsheet. There's different ways we can approach this. I'm just understand that these examples are ways of demonstrating these principles and showing you kind of how it's basically working in the script. You could modify this and approach it in different ways. The last step we're going to do here is add a cluster radius and a self-spacing to each of these. So if I change the self-spacing here to 2, these are going to be a little bit more spaced out. And you'll see again that, well, they're more spaced out between each, it's self-spacing. So it's the spacing between the peach plants or between the yellow plants. And then when they pack, they can pack in and amongst other plants. So it creates a list. But if I make self-spacing much smaller, this will probably be a little clearer. You can kind of see that, well, it's maybe not super clear. Part of this might have to do with the packing step. Like it might be, that's interesting.
Or I think it's because we're still packing it over there too. So
Oh, yeah, we're packing it here. Yeah. Anyway, big plants. There we go. So before I change too many things. Yeah, so the idea is that they can be distributed in this way. And then what I'm doing is I'm creating a quick list of plants where we're grabbing all some new plants in a similar way. We're sorting them out by color, but because it's another line, it's grabbing a different set of plants, a different random set of plants. And then we're setting a different set of clustering and self-spacing parameters. And what you can do is you can take an area that's already been filled with plants, so it has these plants, and then you could add more plants to it. And so we'll plug this in to see what happens. Oops, sorry, Ben.
that's okay.
And we'll see that these other plants fill in around it. What were you saying?
I just want you to make sure you mention the fixed part of the packaging up there as to why that's working.
Yeah. I actually made this fixed false. So what you can do is after you pack the plants, you can actually make the plants fixed. So that if it were to go through another packing round, it wouldn't move those plants anymore. So you can, the other thing that this particular example demonstrates is that we can have a series of fill operations and a series of packing operations. So you can really build your mix and build like the logic of how your plants fill into your site. And you could do this both with this organic fill and also with the pattern fill tool that we have. And the pattern fill actually, if plants don't fill in, there's a thing that shows you the points that aren't filled, and you can use those as the pattern in the next step to fill in where other plants have not filled. So it could be similar. And then I'm just doing the same stuff. I've got my blocks and my schedule here. So this is a little bit different approach, and it's more organic. It's more about, proximities, and it's more about densities and spacing. And some people are going to think about planting that way, or maybe a certain project wants to be more like that than kind of this, image driven or shape driven approach to planting. All right. I'm going to take a breath and let Ben move on to the next piece here.
I think
What is the next piece? I'm trying to
next
remember.
piece is the rules, and I think that's one.
Okay.
I'm glad that we're getting started on this one before the end of the hour
Yeah.
here, because this is one that I think probably is a little bit more direct related to those of you who are trying to utilize these tools for using specific rules, kind of like what Ishan was talking about with salt tolerance, but then also layering in things and adding sort of custom approaches and different types of analysis together inside of the script itself. And so when you open up this file and you're looking at the script, you might initially look at this and go, wow, this looks a lot more complicated than what we were seeing before. But I'm just going to zoom in just a touch just so we can see what's happening here. But it's really not that much more complicated. And I'm going to draw a little bit on the screen here to show you the different areas of similarity between what we were seeing in the other scripts and what we're seeing here. So in general, we again have our plants coming in from a CSV or pseudo plants. And we're going to show you that we have the reason why we had you update to the beta 2.0 is specifically for this file, because we're doing two really cool things in this file that we're going to get to, which is being able to create trees using the planting tools, and then use those tree representations to cast shadow on your site that are going to affect the understory layer of herbaceous plants that we're then planting underneath. So now you have, like Chris was talking about, the ability to have sort of two avenues of plant filling that are coming in. And in that case that Chris was showing, we're filling in plants in a particular way, and then taking all of the empty areas and filling them in with another mix of species. In this case, what we're doing is we're actually creating trees, and we're specifying those trees, using the importer from the CSV and filtering the plants in particular ways. And then we're also doing something that is kind of unique, which is taking that tree and using its smallest height and radius and its highest height and radius, and giving it an age for us to indicate how tall or big is this tree throughout its lifetime as it's growing, and how is it growing going to affect the shade that is being cast on the site. And we're actually using that tree representation that is getting bigger or smaller based on the age value that we're inputting. And then we're using that with the environmental analysis of the sun exposure to cast shadow for our plants to be placed.
So full stop.
Yeah.
Ben, I think this is worth like moving a slider and showing them
Yes,
what happens.
We should actually say, I'm going to
Like
go into
maybe zoom in on this just a little bit onto the site, just a tiny bit, and then
I was
like
thinking of going
show.
into 3D view so you can actually
Oh
see
yeah,
how
3D,
rich
3D.
and like get that like look and feel to it. That's really,
Yeah, we got to wake everybody up. It's like the 11th hour here, and
yeah, everyone's brains are probably mush from looking
yeah,
at
and maybe
that.
even a rendered view possibly.
Yeah, good idea.
So colors are looking hot. Shaded view, yeah, the shaded is great.
Maybe a shade will be a little bit faster. So you can see these tree representations here, and there are a couple, it looks like maybe 3 or 4 different species of trees that all have different shapes and sizes. And we have this component here that allows us to set the age of the tree based on the max size and the min size of the tree in the database. And so we currently have the tree set to a year of 15. And if, let's say, we wanted to see what the trees would look like very shortly after planting, maybe it's a 2-year-old tree we're planting, we can type in the value of 2, and it's going to reorient the size of that tree and then use that tree to cast shadow on the site with the buildings that you're seeing here. And then it's going to place a new set of plants based on the shadow that's being casting. And right here in the foreground, you can actually see our sun shade map being cast here. I think it's maybe a little bit jumbled here, but you can see our trees now are really quite small at year 2. But let's say we jump it up to, let's say, year 7, and we're going to see the trees grow, but then our plants are also going to change based on the fact that our sunshade map is also being modified by those tree representations. And so this allows us to really see and try to understand, at least in some general way, how the succession of our site is going to happen. Like, our trees are going to grow. How are our plants going to change based on the fact that some plants prefer full sun? Initially, they'll be in certain places, but then over time, those areas will get shaded out by the trees growing. And then all of a sudden, we have a different set of plants in that area. So that's generally kind of one of the really cool concepts that are happening in this script. And we're using a variety of different tools here, but just generally, so that you understand a little bit about what makes this script different from the others and how it's similar, is that we have our environment that's being created here. So we have the same zone here that's creating an environment, and we're just using some very basic values here that I'll talk about. We're using some height parameters, and I'll show you how those work a little bit too. We're importing plants as trees, and we're importing plants that are herbaceous layer, pseudo plants and CSV. We can kind of use whichever ones of those that we want. We have an add pattern to area so that we can place our plants in a pattern. And we're doing that, I think we're actually doing that down here. We have this one up here.
Connects, yeah.
Yeah, they connect. And then over here, we're actually previewing that analysis of the sunshade. We're baking our plants and creating our plant schedule here. We are, all of this is associated with the tree age placement. Actually, right through here is our tree age placement. And I'll switch to blue here. So here's our environment. And then this is also a part of the environment. And we have it down here because this is the sunshade analysis that the trees are casting shadow within. So we do our initial environmental analysis up here, and then we have our sunshade, our sun exposure analysis pulled out so that we can associate it with the trees sort of visually in the script a little bit easier. And then up here at the top, what we're doing up here is we're actually taking our area. So if you're familiar with some of the Topo tools in LandKit, what we're doing is we're actually creating these different areas on our site. And then we're actually isolating specific zones on our site that we want to place plants inside of, while still having those other areas being represented as geometry in our site. So we took our planting zones that are being created based on the areas that we're generating on our site, and we're pulling those out and using those in the planting tools. So if you zoom in a little bit to this and look at it, you'll see some components like pull area by name. I'll zoom in a little bit closer. No, that's useful. You'll see that we're using some of the familiar tools of the Topo tools, such as creating areas and collaging those areas, which generate the different material zones on our site. And then we're actually pulling out the planting areas that we're then using those planting areas for our actual planting zones that we're adding a pattern to. So we have now Topo and planting tools working together simultaneously to give us this result that you're seeing here, where we have these paths that are generating across our site that are pushing into our planting areas that only have plants inside of those particular areas based on how we've sorted them in our different material areas for the Topo tools. And then
Ben, will you open the is there an areas? Yeah, acidic area. Oh, it's called acidic areas.
Oh, it's called acidic areas. Okay.
Yeah. So we have 2 different paving types. We have a planting type and a paving center. And if you zoom out a little bit, I think those should be visible somewhere. Oh, maybe we didn't use collage there. I can't remember. Anyways, so we've defined those areas, but then later we can say, okay, once all this stuff is combined, pull out those areas that are of that name, like planting, right?
Yeah.
The other interesting thing we're doing is this legend was originally made for the acidity layer. And so then if you just
That's
changed
why.
which layer we're visualizing, it's like a little legend. And that's what makes the script more complicated as well, is that we're visualizing the different acidity for each zone. And so not only are we solving for sunshade, but we're also solving for acidity and for this distance, size by distance. And so it's the distance to this center line. And the closer you get to that, the smaller the plants have to be. And as you go away from that center, yeah, that's a great diagram. That's the section. So that, that's the planting zone. And then there's the paving zone here. And they have to get bigger. So, it's kind of like, generally it creates these horizons that when you're looking out, you can see all the plants.
Doing
So that's
transportation, planting and transportation areas where cars are driving around, sometimes that scaling of plant sizes based on sort of a turning radius is really important. A simple but very applicable concept that I think we run into sometimes when we're dealing with like designing around
yeah.
some vehicle and transportation networks.
Ben, can I talk about pseudo plants?
Absolutely. I would love for you to talk about pseudo plants.
So you can see here where we have all these plants that say PS whatever. That's not PlayStation. Okay. That's pseudo plants. So it's a randomly generated plant. And this is something I've created recently. And you give it a number of plants that you want. It's a very simple script, but what's happening under the hood is crazy. You give it a filter and you say, oh, I just want, in this case, a 3 means herbaceous. Like if you hover, you can see 3 is herb. And then you have an activation button. And what happens is it creates an herbaceous plant, and it says, oh, it's herbaceous. So therefore the color and the sun and all these, the structure and all these things are going to be based off of that. And it creates a bunch of randomized parameters, but those parameters are all contingent upon one another. And so it creates a very plausible plant, right? So it's not just a pseudo plant in the sense that it's a random width and height and color. It's like a pseudo plant in the sense that it is like very close to something that could be a real plant in this case. And it does that 40 times, right? So it creates 40 of those plants. So all of these plants are kind of potential plant typologies that could plug in here. We don't necessarily need 40. We could say, I just want 10. And then maybe the pattern that we're seeing here emerges. The other crazy thing is like, it's defining all of the crazy parameters like acidity or soil acidity and soil texture and all these things. Anything that's in the ERA, this pseudo plant thing is also generating. So it's a much more robust pseudo plant generator than the other one. And these little plants are where we're not filling a niche. Okay, so it's kind of, it reveals to us whether we're using real plants up here or whether we're using pseudo plants, what we're missing, where we don't have plants. And this is partly why we like to throw a lot of plants at a thing. We like to throw a lot of biodiversity at the problem to solve and fill all the niches. So that the just the overview of this is that we're filling based on a few different rules. We assign, yeah, that's good. So we have the environment, and we are adding by layer. We're adding the what does that say? Sorry.
Shape value?
Yeah, shape value. But what does this say?
Oh, pH range.
pH range. Okay, so yeah. So this is again based off of a value that's going to be in our plant database. We want the same exact name because we're going to match those things to get the constraint right. So sun exposure, pH range, soil moisture. These are things that we'll see you know, soil moisture, pH range, sun exposure. These are things that you're going to match. You're going to need a layer to match the data here. Right? That's important. But then the nice thing is that once you've set it up that way, let's go and look at the niches real quick. So when we're doing for our plants, when we're setting those up, all we have to do is say apply the niches from data. So if that plant has the data about sun exposure and about pH in the columns, which we know it does in the pseudo plants, and we know it almost always does in the ERA, it will apply that as a niche, as a rule. You might ask, well, shouldn't we always apply that as a rule? And I would say, yeah, good luck with that. Because if you try to apply sun and whatever, and you try to apply every single plant rule to a plant, you're going to need a lot of plants to fit, right? So you as a designer still have to make this decision about and have some knowledge of plants and say, I know that this is a relatively moist area. These are the kinds of plants that are going to work here. And when I say moist and dry, this is what I mean, et cetera, et cetera. So I think you still need knowledge of plants, and we're not saying that the tools will solve everything. They help you sort things, right? They help you kind of keep your thoughts in order and keep track of those decisions that you've made. And then later down the line, they're gonna make those decisions. They'll place those plants for you according to what you've told it you want it to do. It's not AI that's just gonna, like come up with something, right? And pull something out of its sleeve. You're the one defining these things. And so I know we're at 3:05. I'm trying to kind of like wrap this up in a certain way. I do have a bonus demo that I can do, and I'd like to share with you. Unless there's any other thoughts from Ben, just in general or on this particular thing.
Yeah, one question that came up that I kind of briefly wrote a little comment in is being able to set different tree groups at different ages. And essentially, kind of following this idea of being able to create multiple different layers of imports of plants and placing them. You could do the same thing with trees, where you could have a set of trees that are being imported that you could actually specify exact names of species that are at certain ages, and then have another a copy of this down that imports another set of species of trees that you can set to a different age, and then have all of those coming out in the way that we have here, filtering into the way that we're applying that to the sun exposure. So a very simple and easy way is to just only have to copy a very particular part of this script that then allows you to have different ages for different groupings of trees or different specific tree species that are going to come in. And again, you could even start to layer this where you say like certain trees are your initial tree placements, and then that there are certain like hardier trees that are going to grow up after that. You could create whole forest successions out of this if you start to get really intricate and complicated. But obviously that's like,
Yeah,
a very
it's
particular.
what the neat thing about this system and the framework is it can be really bespoke to like a really specific project. Like, okay, we know we're gonna have these 3 layers, or we're gonna have these different zones that have these specific plants. But it can also be very procedural, right? Like in different ways. Like you're like, I don't want to. I want to be able to put in any list of plants, and then it reacts in a certain way. Um, or whatever. And so it kind of depends on your knowledge of Grasshopper. It depends on how complex you want your project to be. We're always here for you. We have office hours every week that we can help with something if you're having trouble. We also will do consulting if you want to hire us to do that as well. Um, we've done plenty of that on projects. We've built whole tool sets for teams that are really specific to their application of this. But we also do really encourage everyone to sort of dive into this and learn how to use it themselves, and if they think that that's the right thing for them. So let me do the bonus. Should I do the bonus?
Yeah, I think the only
thing?
other thing that I wanted to mention that's kind of sort of a big picture application is that we're using this sort of approach where we're allowing the trees to change size and update the conditions. And this update conditions doesn't have to just apply to updating the sun exposure values. Like you can apply this in a lot of different ways. You could even have the update conditions changing the pH values of your zones potentially based on whether or not you're early in the spring and you have a lot of changes in your pH based on salt runoff over the winter time. And then maybe later in the summer or fall, your balances have gone back to normal and maybe your plant species are changing or something like that. But the update conditions is just really a way of being able to kind of see different environmental conditions change based on how certain values are changing over time. But
Yeah.
the sort of the most readily and easily applicable way to see this is using that update tree age or update plant ages, such as shrubs or trees or other things, to see
Yeah.
those things happening.
And then we're using the trees themselves as something to cast shade, right? So if they get bigger, if they cast more shade, and then it compares the areas that we've already filled with plants and says, okay, which ones don't work anymore? And that's where we fill them with these little green plants, right? So it says, okay, if it's removed those plants, let's refill in and show the green plants. That's what's happening here. And again, I'm like re-explaining all the stuff from Ben, but
No, it's great. It's always good to have
the and as Ben said, this could be the sun, but it also could be like changing soil fertility or changing soil wetness based on some kind of like changes are going to be happening over time. And it just like it really adds the element of time, and it gives that one little component allows you to sort of say, if you update the conditions, you can see what it is at 1 year versus like 15 years or 30 years, and you can change different elements of an environment, and analyze at a different time frame. So those two new components are the pseudo plants and the update conditions. Those are brand new. You guys are the first people to have those outside of Landau, with this beta, other than people who installed it earlier today and are already, which who's doing that on a Saturday in the summer. But yeah, so let me get to this last demo, and I will share my screen. And I'll try to make this relatively reasonable
And again,
here.
anyone that needs to leave now, again, there's going to be a recording here. So if you need to leave now, you'll be able to follow up on some of these concepts that Chris talks about afterwards.
Yeah, absolutely. Do we have anybody? Yeah, you could definitely do based on sea level. So I have this last example is really using topography, which we've been looking at areas, and we've been looking at planting, and we've even been using paving, but we haven't talked too much about topography. And I wanted to show as like kind of an advanced example how you could think of topography. And what we're doing here is we're saying, I have a center line. From that center line, using our Topo tools, I can create a path. And I have a path width and a path slope. And so you can see the contours here are following that slope. And so let's see if I can like maybe give a little bit more room on this. I've made my interface a little bigger so for the Zoom for you guys. Let's have there we go. Okay, so and then I have some break lines that are defining an outside boundary of a topography. And you could define this in different ways, but let me go into 3D to show you. So actually, this is a break line, but it's at a slope. So this could change a little bit. Like I could take one of these points and pull it down a little bit. And what it's going to do is it's going to update the topography, and it's also going to update the plants and where they're placed on that terrain, right? So just as a reminder, when you have terrain that's going into an environment, it automatically places the plants at that terrain elevation, which is amazing for 3D rendering, right? It's really great for 3D rendering. Could also be used for other things, but it's pretty awesome for that. So better plug in my computer. So that's topography. And then, some other familiar things like getting our plants, assigning a cluster radius. I'm not doing that because I'm finding that the cluster radius in this particular instance is taking it a significantly longer time, and it's really not the point of this particular demo. So I'm removing non-colorful plants, and then I create a really basic environment as a starting point. We fill it with a pattern. And yeah, so what's special about this? Not a whole lot. I just want to sort of give you the overview of like this general setup. So the topography is a little bit more of a thing here. And then we're using that path to create areas. So we have areas that are now also being projected to the topography. So it's dynamically creating a path and collaging that path with the site material, which is essentially all the planting area. And then we can pull out that forest and use that as our planting area. So it's kind of integrating the area system, the topography system, the paving, and the planting. It's all connected in one big script. So that's pretty straightforward, though, because we're essentially taking and building topography and placing plants on it without really any rules. I have this additional version of this down below. So let's just, I've disabled these components down here and enabled these. And what I'll do is I'll just do under edit, I can say, solution, I can say toggle enabled or control E, and that will make all the ones that were enabled disabled and the ones that were disabled enabled. And what that does is it turns on all this script down here and it turns off all of the script up here. And we'd like to do that if we have, it's great for demos. It's also great if you have like, okay, I'm working with this part of my script and now I'm going to work with that part of my script. And for whatever reason, I like to keep it all part of one system, right? In a given instance. Oh boy, I don't know what happened here. I'm just going to say close. Okay, so now it's filling plants, and it looks like it has a lot of plants, and I'm going to start by changing the density. So this is something I do a lot when I'm working, is I say, okay, I don't want to wait for this to work, but I know I can always change this density back to 1 foot spacing. Right now, I'm like at 3 foot spacing, and things are going to work a bit faster. So I can see that I have a few things happening. So I have topography. Alex, good to go. So we have topography, and then we're analyzing. We're using. Let me slow down. So let me zoom in and sort of give you the overview. So we create topography using the path, but then we use an image in our environment, and we can actually use the image and the tape to create topography based on that image, right? So we can push the topography down a little bit according to the image, and then we can override that in the area where the path is. And I do all that using a formula. And so that gives us our kind of final topography. The way that works is that we have, we start with our area. We get the elevation. We add an elevation layer, which we haven't had to do yet because we're not dealing with everything's been flat so far. We add an image layer, which I'll show you that image. Actually, let me Let me show the image. The image looks something like that. So it's the same cell image that, and then, so I've added that, and then there's this cool thing where you can diffuse a layer. So I'm diffusing that layer a little bit in order to create a softer representation of that cellular image. And then I also create a shape layer for using my path. So it's like either on or off. So it's using the path is on and all the rest of the space is off. And then I diffuse the path layer too, because I want that to have like a soft edge. Then here's the crazy thing. Taking the existing elevation layer, I multiply the image layer times the path layer times 3. I add that to the elevation, and then I also add a little bit more for the path. All right, what's happening here? Yeah, so I was tinkering around with this formula, like, oh yeah, like make this a little more, make that a little less. And it's an interesting way to take all these layers and to do, if you're familiar with GIS, to do what's called like map algebra. And you take the different layers and you can treat each layer as a functional parameter, right? And you can create a whole equation doing that. So that's neat. So you can create a whole new layer that way. But look, I didn't create a new layer. I created elevation. So I'm actually manipulating my topography based on this these changes. And if I turn off all this other garbage, so turn off my plants, and I'll turn off this water analysis thing. Where's that? It's here. This is the topography that results. So I have a path that's high and dry, right? It's not getting inundated with water flow. And then I have all this kind of varied conditions for plants. Plants really like varied conditions. Like we make all these smooth spaces, but this is one of the things that's going to help us build biodiversity, which is having areas that are wetter or drier and creating a greater diversity in the landscape to create greater biodiversity. But we can do this procedurally using scripts. Now, the next thing that I do is I analyze where water flows using the water flow tool, and this sort of sees where water goes. And then over here, you can see that we can create an occurrence layer of where most of the water is going. We can diffuse that a little bit to kind of think in terms of like wetness, more in terms of wetness. We can also add what's called an upslope area layer. An upslope, it's sort of like the flow, but not quite. It's like how much area is upslope of a given square foot of space. Like how many square feet is upslope of that square foot. And then I use another equation to sort of combine the flow and the upslope. And I give the upslope way less weight here. And then out of that, I'm going to get some values that are just sort of factor values. And what I've found is that 5 is somewhere in the middle. And I can use that to assign like anything that's less than 5 is going to be dry, and anything higher than 5 is going to be wet. And then that gives me this map, which is wet versus dry areas. I can use that as a layer. Sorry, I know I'm zooming around a little bit, but I want you to understand the whole idea before we get into any super weeds. I can apply a soil moisture rule and a height rule that are both based off of that image. Therefore, when I place plants, you can see, and here's where I'll increase my density again. You can see that if I have like, I'll just do 1.5. You'll see that pattern that I have in the map is going to be reflected in the placement of the plants as well. So we get these sort of green zones that are, the green, and I don't know if there's blue plants there. That would be hilarious. So, blue is wet. I think it's actually just the flow lines. Yeah, so those are some plants, and I can go here and say, okay, I want more plants thrown at this at the beginning. So I'm going to do 50 plants, and it will refill based on those rules. And we should see, yeah, so there's like a different distribution of plants here. And different mixes are going to be clearer than others. So, it looks like we have some like some pretty large plants this time around. But it creates some questions about, again, it's having a generative approach allows you to sort of get outside of your preconceptions of what you should be doing and start to kind of start defining the problem and allow yourself to then explore a space that's within the constraints of the project, but is maybe a little bit more random outside of that, so that you can say, wow, that's actually a fascinating idea. What if we had like sort of larger plants in these wetter areas, and maybe they're even just taller trees or something. And then I can plug in that slider again, and it'll completely re-randomize. It should re-randomize it. And I get a new set of plants, and I can see, what those plants are there. Are there any questions about how I got to here? I know I skipped over some parts. We have we have effectively a series of transformations to create unique topography based on the path and based on these sort of mounds, all based off the image. And then we take that topography and we analyze its water flow to create these zones for planting, right? We're really creating the conditions for the planting, and then the plants are being placed based off of the rules with those conditions. And that's kind of the cherry on top there. If you guys are interested in diving into that script, I know that's going to be a more advanced script, but it's something that you could investigate maybe in a few months after you've investigated the other scripts and become more familiar, and you can revisit this video.
But also
the environment is a whole other thing, like the environment and all the things you can do with it is sort of something we don't dig into as much here, but I thought it was really worth mentioning. Go ahead.
And I was going to say too, Chris, is that, another way to kind of keep your brain moving on some of this stuff as you start to poke around and look at these scripts a little closer is that's part of the reason why we started office hours is, I'm just on a Zoom call, or one of us from our team is on a Zoom call, just sitting there ready to help you understand or reconfigure things or modify things for an hour on Tuesday and an hour on Wednesday each week, where you can just log on during that hour and just, it's a first come first serve. So if multiple people sign on, I'll try and divide the time between the people who are on. But every once in a while you'll get lucky and you might be the only one on there, and you might get almost a full hour of just helping you understand certain parts of the script, or helping you reconfigure the script in certain ways that are confusing, to help you use it for a specific purpose. So that can, if you're diving into a project that is really modifying a script or applying it, that's probably a better situation to come to us with some consulting work, and have us sort of like really focus on you specifically in that project. But, especially as you're diving back into these scripts, rewatching the video and just trying to get a better understanding of what's going on, office hours are a great way to get help on that. Oh, we lost your voice, Chris.
Yeah, at least I didn't lose my voice. So we have the mini workflows, which we've been doing, and the mini workflows are free videos that show you how to like use a few components. And we have mini workflows for analysis, for topography, for paving, and we have some that are like we're working on for planting. So if you really are like you're serious about learning more and more about this, like those videos are also going to be, freely available, at least for all these basic elements. And and you're like, I still don't understand what they mean about this thing or that thing. You'll be able to go and have another reference for that. Yeah, they're available. There's a lot available on this campus page. So our component library, which explains components, the workflows. We showed you the planting workflow and the mini workflows, which are more like tutorials, and like little scripts that you can use, but they're also just as much a tutorial about how Grasshopper and how LandKit work. Um, and there's a whole list of them and a playlist that you can access. So what else? What else is new? Oh, next week is the tree workflow workshop, which is freely available. It's a new workflow that we've created for soil cells. So if you're in an urban environment and you want to plan where silva cells go, and you know where certain utilities are, you have topography, and you've got all these complicated things, this will help you solve that. And that's Youts has been working on that script, and Ben and I have been helping. And, where we actually have been consulting a little bit with Deep Root on silva and merino cells, and we're hoping to kind of bring in some other vendors as well to kind of make sure that we have the sort of the field covered with the different soil cell types. We also would love to do more with the different like aspects of plants, of trees. So like how tall trees are and how they might interface with other pieces or other aspects of the soil, things like that we want to we want this to be not just about soil cells. Eventually, I think where it's like you can cut a section and you can understand all this stuff under the ground, or maybe even over the ground relating to trees. Yeah, root depth and type is definitely
Especially,
something we're looking at.
yeah, relating to like erosion control and things like that. And also in terms of companion planting and what kinds of plants you put together.
Yeah. And again, with the workflows, it's always this question of like how far outside of a locus point are we going to go, right? How far outside of like a standard sort of workflow are we going to go? In our Topo workflow, we are, it's a great example of how we really include so much of what you can do with topography. With the planting workflow, it's pretty limited. You saw all the crazy stuff we did today. That workflow that we started with was very very limited. So awesome. Well, we're losing people here, so I should probably let you guys go. And thank you for all your time. And I hope you become you stay part of the avant-garde of planting.
Thank you so much.
Yeah.
Thank you
And
so
again,
much for
yeah,
informative. Yeah.
absolutely. If you have questions, we have office hours and we have other means. So let us know.
And we should have an unlisted YouTube page out to you all sometime soon with this video.
Okay,
Chris
great.
Yeah, we'll
yeah,
share that.
yeah, just a quick one, Chris and Ben. I'm like we're talking about this is very, very useful tools. And how about like the output, the production, like
Yes.
the drawings and
Yeah, there's a lot of different ways to think about that. But basically with plants, it's primarily the blocks. You're getting blocks that are coming out. And the neat thing about that is you can replace those blocks with land effects blocks or with your favorite
yeah.
CAD blocks, or maybe you're going into Revit and using some sort of workflow to go into Revit. That's most likely something we will be adding capacity for in the next planting workflow.
Yeah, we had
Um,
started the Revit one and Slan FX
yeah,
have tool in Revit, so we have started that, but it's a manual placing. So if we have this tool
yeah.
incorporated with that one and it will automate the placing of the plants, that would be amazing.
And that's where
Yeah.
we're really trying to look at the planting tools, and something that Chris emphasizes a lot in workshops like this and broadly is that we're not trying to reinvent the wheels that are already on the sort of car of planting design, but trying to add new features that make our lives easier. So Land Effects, Revit, a lot of these software have really great like documentation setups and layouts and tools, but the actual getting to the documentation part is still like this crazy process that's very manual. And so that's where we were really like just trying to make the interface between these different software. So if you have other software you use or you know or you're familiar with that is being used a lot in your office or other offices, we would love to make sure that we're getting outputs that match those software as well.
Yeah.
That's nice. Yeah, it's amazing.
Yeah, we're
We
trying to
do.
solve for most cases, but sometimes people are like, well, we use this and then we use that, and like, why doesn't this work for our process? And it's like, well, you're a unique case, or there's very few people who do your exact unique thing. So it's tricky to solve for all the use cases, um, but we again, we do consulting where if somebody's like, I need to start here and end here, like we could help you. We could retrofit the planting workflow, or we could retrofit, like you can say like this script is perfect, but we just need it to do these things. We could help you kind of do that if you're not able to to build your own, right? But we're hoping that the tools make it easier and lower the bar for more people to be able to do that.
Yeah, sounds great.
Awesome. Thank you guys.
Yeah, thank you all.
It's good hearing from all of you, and don't be strangers.
Okay, thanks everyone. Nice meeting you all.
We'll definitely be in touch.
Okay. Cheers.
Thanks, Allegra.